So thanks for everybody coming out. We appreciate you being here for the first Arduino day. We're making it up as we go along too, so relax and enjoy it. We planned a couple of talks today throughout the day in addition to the various demos and so forth. And I asked Nick Uhlman to kick it off because he is always fantastic at both presenting his work and making really wonderful work. Nick is an independent musician here in New York who is also an alum of ITP, also a faculty member of ITP, and has been making some really wonderful acoustic musical instruments with Arduino for quite a while, which you can see downstairs after his talk if you're interested as well. Take it away, Nick.
All right. Really pleased to be here to celebrate Arduino. As Tom said, I'm Nick Uhlman, and I'm going to be talking about a lot of the work I do with kind of musical robotics involving Arduino, and particularly a platform that I've been developing over the last couple of years called Briccolo, which is sort of a way to open up mechanical music and kind of acoustic instruments controlled with the computer to a whole range of digital musicians. So here is sort of what a kit that I've been putting together looks like. Several modules, which I'll get into in a little bit more detail later. But the basic idea is that if you're making music with a computer, so if you're working with a sequencer, as most musicians are at this point, whether it's Ableton Live or Pro Tools or Cubase, and you are tired of only kind of having your output be something that lives within your computer, so synthesizers, samplers, drum machines, this is a way to use that same sort of precision, that same sort of ease of programming, but have it actually be realized in the physical world. So taking the same MIDI signals that a synthesizer or sampler would use, and then actually being able to control physical objects, whether they're acoustic instruments or any sound that you want. As Tom mentioned, I've been doing kind of this work for a number of years myself as an installation artist. So I do what I call song installations, which are an arrangement of robotic instruments that I write music for. And then it's usually something that I kind of spread out throughout a space and really encourage listeners to sort of sit within the arrangement of music and kind of explore how a song is put together acoustically. So I'll just show you an example of the most recent one of these I did. This was from last summer at a museum in Paris called the Palais de Tokyo, which is a big art center there. And this is a big collaborative project with a number of other artists, including a group called Rabbit Hands, which does these wonderful installations with scavenged materials. And so the structure that this is all situated in is all built from scavenged materials by this other group of artists. Here's a video. So that's just a little taste. So that was, as I mentioned, kind of a large-scale installation that I worked with a group of other artists with, and it was called Concert Hall, and it was a cycle of about a dozen songs, some that I wrote and some that were written by a wonderful French musician named Julien Gasque, who's collaborated with Stereolab as well as others. And so it's sort of this robotic concert with no actual human presence, just these sort of disembodied voices floating in, and accompanied by these robotic instruments, so people could kind of explore and really be within the music. And so I've also used these robotic instruments for live performances, sort of as a backing band, and recorded some albums with them as well. And And like I said, I really came to this because I had been making music with computers for quite a while and really loved the precision and control that you have with a digital production platform. So it's amazing. You can kind of create all these layers and multi-track, very complex arrangements. But then when it comes time to actually present that work publicly beyond a recording, there's a frustration that I think a lot of people have with having to just do this. So this is Girl Talk, putting in a very vigorous performance, obviously, but still sort of just trapped behind a laptop. And there's not really much transparency as to what's going on with the music itself. And so, I was interested in figuring out a way to kind of make the music more visceral, but still be having that digital control and really get back to sort of this feeling. So this is an example of 19th century parlor music, which was really, before recorded music. Chances are your experience of music was sitting around in a small space with friends or family and playing instruments. And of course, mechanical music also played into this scenario as well. So as player pianos became popular, that might be your home entertainment system as well. So I was interested in sort of extending that legacy of mechanical music and making installations that really invited people to have a very intimate and kind of immediate experience with the music being played around them. So here's just another example of an installation that I've done that tried to evoke that. So this again is sort of a series of instruments and a song cycle that I wrote, played among them, and people could really kind of wander through and hear the different sounds and have the sounds be very spatialized within their own space. And I also sometimes use these setups to do interactive works. So often with a simpler music program, and this is actually a piece that I have set up downstairs, so if you want to come play with it, but I'll just show a brief demo. So this is a piece called Animal Magnetizer, which also uses a Kinect for some spatial sensing, so that as viewers hover their hands over each of these sort of instruments that has these mechanical modules on them, they're triggering them. And it's a kind of inviting people to collaboratively mix a song. So loops that are all playing in sync, but you're sort of activating them and just giving voice to each of these instruments. Yeah, so as I said, it's partially a way to kind of give people who don't necessarily have experience playing music sort of an opportunity to get inside and mix the sound, and also to collaborate with each other. So as the instruments are spread across the space, you really need several people to activate everything. So it becomes kind of a fun interactive experience. So I'll just go through a few build photos. So this was an early prototype of the MIDI hardware in a Tupperware container, as we all like to do. You can see there's plenty of Arduino involved in this project. So basically, this is just taking a MIDI input from the computer or whatever other sequencing hardware you want to use, and then it's just routing out for each MIDI note. It's routing out DC current. I use typically 24 volts to one of the solenoids that's attached to the actuator modules. So you have a control box where you can map MIDI notes to specific instruments. And then this is the current build for the circuit board that I designed, but it's still essentially an Arduino embedded in the board there. And fans of OSH Park will recognize the distinctive purple and gold board there. And then, as I said, this is sort of the control box. So here is the routing system. So it's just using RCA jacks. And really the goal with this is to develop a system that I have several modules I've developed, but if you would rather build your own pieces, it's very easy to connect everything up. So it's just sending, as I said, 24 volts out through these RCA connectors to these modules. And this is what the current sort of basic set that I've been putting together. And I've been able to offer this in a limited way to other musicians who are interested. So really an international group of musicians from Australia to Sweden to Germany have bought these sets and are kind of now using them in their own work. And I'm very, very excited to see what they wind up doing with it. And I'm really working towards making this more and more available to people. So the basic modules that are in the current set are this, which is fairly self-explanatory, a drumstick that mounts onto a microphone stand, so it's very easy to position over a drum or whatever else you want. And then this module, which I call a surface popper, which is a smaller solenoid, a smaller actuator that sits on this little platform, and it's whatever surface is placed on there, so whether it's a drum or in this case a book, becomes the sound source. So this little solenoid plunger just pops up to strike it. And so I use these for percussion sounds, a lot of the kind of high-pitched sounds that you heard in those installations, including those that were hanging from the ceiling in that first installation. But I also have been using it for something I call the thing synth, which is a way of actually generating tuned notes from physical objects. So basically a synthesizer that plays things, physical objects. And that's using this same module, but in that case, the control hardware, instead of just sending a single pulse for each MIDI note, it's actually very rapidly pulsing that actuator at the appropriate frequency for whatever MIDI note is coming into it. So I'll have just a quick demo video that shows that here. The Thing Synth module goes beyond percussion sounds and lets you play melodies and bass lines on physical objects. Changing the properties of an object is like dialing in new settings on a filter. Control invites digital music makers. So all right, that's enough. So this is a really fun one, and I've found books are particularly lovely to use with this because they have this sort of built-in, variable volume. So it really does sound something like sweeping a resonant filter on a Moog or something like that. In general, as Tom mentioned, so I teach a class here at ITP, which is about automation and kind of using it for creative purposes. And in general, one of the things I encourage people to explore is using MIDI or using OSC or these other systems that have very easy to use, sophisticated software for creating complex sequences to control whatever it is you want to control. So, I mean, I'm using this for an explicitly musical purpose, but you can just as easily use Ableton Live or any other MIDI sequencer to control really anything that you want to control with an Arduino. So this is just a quick example video that I put together showing using MIDI to control, still a musical instrument in my case, but instead of strikes of a solenoid, the sweep of servos. So using, in this case, so just to briefly get into it, typically a MIDI message has 2 bytes that you're sending to it. So it's a note message that's saying turn this note on or off, and then a velocity message, which more or less corresponds to the volume level. But in this case, I'm using the velocity note. So basically just another chunk of data that you can use for anything you want to control the angle of 2 servos that are on a little pan tilt head. So here's an example of that. So as I said, again, I'm using it for musical purposes, as is my want, but you can imagine, if you've built this robot or this robot arm and you're having trouble doing all the complex timing programming that is available on Arduino, but it does get kind of gnarly. Hooking it up to MIDI and being able to control it with a really easy to use interface like Ableton or any other sequencer is a really convenient and nice kind of thing to be able to do. And this is also great if you're trying to sync any of your creations with music or lights or whatever else it is. So it's something to explore and encourage you to check it out. And I do have some tutorials on the page that I have set up for the class that I teach if you're interested in looking at more of those examples. Thank you very much. If anybody has any questions, I'm happy to answer them. And also, as Tom said, I've got a setup demoing some of this stuff downstairs, so come by and check that out later.
What kind of sensors were you using with the animal magnetizer?
Right, so that was actually using a Kinect. So there was a Kinect positioned in the back of the room and basically drawing in little target areas above each of those instruments. And so that's using software I wrote in processing, and then that's sending MIDI messages from processing to Ableton to trigger different tracks on and off with a loop that's kind of constantly going.
So Ableton was your MIDI program that you used on your laptop then?
Yes.
Okay. So then how did that translate into 24-volt signals?
Right, so that's basically what these control boxes, so that's what those are doing. So this is a MIDI jack here, kind of standard. And you can do MIDI, there's a MIDI in circuit that's documented everywhere on the web that you can use with more standard MIDI hardware, but there's also plenty of, if you just want to use direct serial from your computer to Arduino, there's plenty of kind of MIDI interpreter programs that very, very easily interpret that and kind of send it off as MIDI notes. So it's basically MIDI in going to there, and then 24 volts going into this, and then that's being routed out from these connections. All right. Thanks, everyone.
For our second talk of the day, we have Nick Ullman again, in a new disguise this time, as an employee of Kickstarter with Giulio Terra. Those of you who don't know Kickstarter, anybody not know Kickstarter in the room? Good. Okay, so Kickstarter has been a great source of really interesting Arduino-based or Arduino-derived or Arduino-inspired projects. And we've had a lot of conversations back and forth with Nick and Giulio and John D'Amatos of the product team about how we feed into their ecosystem and vice versa. And they've done some really great thinking about it. So we thought we'd just open up a general community discussion around it and let them take it away. So thank you guys for coming on.
Thanks, Tom. Hey everybody, I'm Giulio. And you guys have already been introduced to Nick. So both me and Nick, along with John, we are, our title today is Project Specialists. By next week we're going to be called Community Managers, but we're essentially responsible for working with creators and looking at projects both in the product design as well as in the technology parts of the Kickstarter ecosystem. And on a personal level, all three of us have studied at ITP, and we all work with Tom very closely, and we're all big fans of Arduinos. We all have our own Arduino projects and prototypes that we do. So it's, I think, the Arduino community specifically is very close to us, and it's very kind of something very important to us on a personal as well as kind of on a in terms of what we like to see on Kickstarter.
And I think it's also just the ethos around technology that Arduino represents is exactly what we want to see on Kickstarter, like openness, really inviting people to take part in the creation of something really cool and really exciting.
Absolutely. So just a few numbers about Kickstarter to start off with. Just a few weeks ago, we actually reached our $1 billion pledge. So that means that we launched about 5 years ago, and in this 5-year period, we've had people pledge over $1 billion to projects. 80% of those projects, a little bit over 80% of those projects were successful. A little percent of 80% of this money was pledged to successful projects. Actually, about 44% of projects on our site actually succeed. That means this number was $1 billion was pledged to thousands and thousands of projects, somewhere around 70,000 projects, around 58,000 of which was actually projects that were successfully funded. And and these projects, of course, span everything from music to theater to art, film, technology, dance, comics, publishing. So it's really kind of a really wide range of stuff. I mean, here today we're going to, of course, focus on specifically not even just technology, but specifically the Arduino community on Kickstarter. So Arduino projects on Kickstarter specifically, these are kind of some facts and figures about that specific community. 62% of Arduino projects on our site, and of course, this analysis probably is not every single Arduino project that's ever been on the site. We just kind of did our best to kind of do some research and pull some data. But Arduino projects on our site are pretty high. They have a pretty high rate of success. 62% of those projects are successful compared to our site's average of 44%. And what that just goes to show is that there is a really kind of vibrant community of people who are Arduino fans and who are looking for Arduino projects on Kickstarter. And and I think that's something that we kind of see not only through this number as well, but just you definitely see a lot of those projects that are related to Arduino have a lot of kind of comments on the projects. There's a lot of buzz around them because it is, again, just a community where there's a lot of people on Kickstarter who are kind of always have their eyes open for those types of projects.
And as Giulio said, so this is just a representation of projects that either in their name or in their kind of short description reference Arduino. There are hundreds more that use Arduino in some way. So whether for prototyping or there's an Arduino that's running all the magic that's happening with the product. So this is most likely just things that are specifically kind of Arduino accessories and things that are for the Arduino community itself. But Arduino has a much larger footprint than just this on Kickstarter as well.
Yeah, and so the types of Arduino projects that we see on Kickstarter, there's a few different kinds. There's some projects that are just literally projects that at one point in their life, they were using an Arduino to prototype some type of hardware. So that final hardware, their final product that they're releasing to the market may not have an Arduino in it, but it was, when you look at the prototyping process, they show pictures of working prototypes or previous prototypes that featured some type of Arduino in that project. Some of those, that's the kind of project that's least represented in these numbers because those don't always kind of tout that very strongly. And then we have projects like Arduino Shield projects and Arduino accessory projects. So there's a lot of people who will create, anyone who's familiar working with Arduinos, that Shields is a kind of an awesome add-on to help you prototype stuff. But then we also have some people that actually use Kickstarter to create sensors that are were specifically designed to be used with platforms like an Arduino. And then, of course, you have projects which are the Arduino compatible projects or Arduino R projects, where people are actually developing a project that has that functions that provides some types of functionality that are mimicking an Arduino, or some of them will use the same hardware as an Arduino, same chip as an Arduino, so that they're programmable using the Arduino IDE. And that's kind of I think the three main different categories of Arduino projects that you see on Kickstarter. So just a few, some additional data about like the health of the community. What you can see is there's been almost $7 million pledged to projects that again explicitly mention their relationship to Arduino, either in their title of their project or in their short blurb about the project. As you can see, kind of just looking at the graph, I mean, the number of projects related, like from this community, has increased a lot in the last couple of years. I mean, I think that trend does show that's pretty much you'd see something like that across the board on our site. I mean, last year, out of the $1 billion that have been pledged to Kickstarter, 500 million of that was pledged last year. So that's why you do see this kind of huge spike last year. That's something that you would pretty see across most categories. But again, the thing that we're trying to show here is just how this community is growing. And in 2014, right now, if you look at that, it looks like it's less than 2013, but that's only because the spike when we actually get the most projects is around the summer. So we'd expect to see a spike again this year, of Arduino related projects that's considerably larger than what we saw last year. I'm not going to go through all the other numbers on this page, but it's just kind of that idea that, again, it's a really very vibrant ecosystem. Now we're going to just kind of jump through some examples of projects that kind of have come. This is some of the projects that we personally like, that we think it kind of shows, just kind of some creators that have used Kickstarter to bring fun Arduino projects to life using our platform. And it's we clearly see that there's, like with any platform, like we at Kickstarter, we don't curate projects. We have some guidelines, and projects, if they meet that guideline, whether we like it or like the project or not, they are allowed to run on the site, because it's, our whole idea is that we're creating this platform for the backers to decide where it really comes to life, and we're not kind of the gatekeepers. But at the same time, I think all of us on the team, we definitely have projects that we personally like, and we personally will promote and talk about with our friends and with our communities. And these are ones that I think most of these either Nick, me, or John have backed. So this is one that I backed. This is one of the things that we liked about this project is this is a pretty small project. It was something where their goal was $10,000. I mean, this is not. I mean, we do have a lot of Arduino projects where they are really making a small, tiny board where they're looking for $2,000-$3,000. But this is on the smaller end of the kind of projects in the Arduino ecosystem. But it was just a really nice little shield that lets you create. It was designed for you to do little graphic stuff, either do like video game type stuff, or do these kind of these type of playing around with photos when you kind of do that kind of, I forgot what you call these photos, long exposure photos, where you just kind of move the LED device around and it creates this kind of text or what? Light painting. Yeah, light painting, exactly. And so this is one that I backed, and I just got it recently. I literally got it this week. I haven't actually put it together yet, which I have to say that I have several Arduino projects that I have at home that are shields that I haven't actually put together yet. I have a little stack of them, but which is one of the kind of issues working at Kickstarter. A lot of your salary goes back into Kickstarter projects. You're looking at them all day long. So This is another project that I also backed and I haven't received yet, but it's the One Shield. And this was a really kind of interesting project. It's a little bit, more complex than the DigiShield, the DigiPixel. It actually is a shield that lets you connect to your phone. So rather than, say, if you needed to prototype something, rather than buy a bunch of sensors, a bunch of switches, you can actually, use your phone as and kind of tap into like the accelerometer on your phone. Use your phone as a switch or as multiple switches. It's essentially, the combination of a shield with low, with BLE, with Bluetooth Low Energy, and with a few phone apps that they create for you that let you tap into those features of your phone. And it's one of those ideas where when I first heard about it, I thought it was silly, but the more I thought about it, the more I kind of liked it. Just because I know how I have an absurd box full of sensors at my house that I don't often use, and I always have my phone with me wherever I am, and this just kind of makes it easy for you to prototype stuff really quickly in a really fun way. And also it was just cool because this was like a hackerspace out of Cairo that was actually making these, so it was just kind of also, it was coming from Arduino community that, in a part of the world that we hadn't really kind of seen be actively engaged on Kickstarter before. But so this one here is actually a really, really awesome little project as well. It was called the Microslice, and what this is, it's just a very small little laser cutter / engraver that has an Arduino inside that kind of does all the, that kind of runs the machine. And and it's just, it's only powerful enough to cut paper. Other than paper, it can, if it's anything any thicker than that, it just can engrave it. But and it's all done with little laser cut parts. It was only a couple $100, or actually about I think 200 pounds. So that's, I guess, $300 or so. But again, it was a really kind of nice little project where just a maker in England put this together, and and this kind of gets to the other types of projects, which again, it's no longer the two first were kind of shield projects. This is one of those projects which is actually a product that has Arduino and is hackable because of that.
You can maybe see it's actually behind Julio, but there's actually official Arduino sitting there running the whole thing. It's really cool. Yeah, so this is a big one, the Makey, which is a very cool prototyping platform, but really also a way, sort of introduction to microcontrollers and Arduinos for people who maybe haven't gotten into programming or haven't done this before. So it's essentially a board that has a lot of really convenient to use capacitive sensors. So you can clip these alligator clips on each of these and attach them to things like bananas, and basically what it's doing is sending key commands from the microcontroller, the Arduino-based microcontroller that's on the board, so that you can hook it up to any website that accepts various key commands to control things, or any very simple program that's already set up to do that. It also is, the hardware on it is a full Arduino, so that if you get kind of beyond that point and you want to start programming it yourself and using those sensors that are built into it as an interface, it has that option to kind of extend your learning curve there. This has been tremendously popular.
Just two points. Actually, it's not a capacitive sensor. It's a high resistance switch. So you actually have to touch two things in order for it to work. But essentially, it's. And then the other thing, I know that this is the processor on here is one of the things that we do. Call these projects. This type of project we call Arduino compatible, because it's it was prototyped on Arduino, but it is actually a project where the board, it can be programmed using the Arduino IDE, but it's not like it has not been kind of tested rigorously to make sure that it kind of works with all the different Arduino libraries, that it works with all the Arduino examples, which I think is just one of those things where we're working harder and harder with our community to make sure that they are technically accurate about like how these different creations actually work with the Arduino ecosystem, because we know that nowadays I think there's a lot of expectations about what an Arduino can do and what an Arduino is it supports. And I think outside of boards that kind of have been tested to kind of work with the full kind of spectrum of Arduino libraries and whatnot, these other kind of projects we will work with the creators to just always make sure that it's technically accurate, like how they their project actually kind of works within the ecosystem.
So this is sort of the opposite end of that spectrum. So from the kind of very beginnings of somebody getting into making things to sending something actually into space. So this is a satellite that's based on Arduino. And what this project did was essentially allowed people to gain access to these very small 10 centimeter cubed satellites with this package of sensors attached to the Arduino. And for a pledge, you could get access to that satellite that was out in space. They actually launched a number of these and run your experiment, kind of upload your Arduino code and run your experiment for a set amount of time. So essentially, have access to an Arduino that they've sent off into space with a sensor package. And here's actual image of the ArduSats floating in space. And you can see this is one of the reward tiers. So for $300, you had 3 days worth of uptime with the satellite to run your Arduino program and do experiments, and then get all the data back for whatever purposes you want. It had cameras integrated with it, so you could take footage and a various array of sensors. This is another super cool one, and this is part of the Arduino at Heart program, which is sort of the more officially endorsed and kind of projects that are working directly with Arduino to make sure that their standards are compatible with Arduinos. And so this is a very tiny Arduino right here with a very small LED display there. So it allows you to essentially have feedback directly on the chip itself. So if you need to have, in this case, see what the sensor readings are, you have a little graphic there. And in this case, it's embedded into a larger robot that's just kind of displaying what functions are being triggered. This is live right now, so it's actually, these numbers are probably not even accurate.
Yeah, and one of the things that we've seen a lot of Arduino Heart projects come through over the last couple of months, which I think is something that we're really excited about. I think there's been a total of 5 projects, Arduino Heart projects, that have used Kickstarter so far to come to life, and all those projects have been quite successful to date, and and it's one of those things where it's just nice to kind of see, and these are all actual products that have Arduino inside so that you can reprogram them and kind of use them in different ways. So now I think the next couple of examples I think are all Arduino.
Exactly, yeah. This is another really beautiful one, and again, an introduction to programming. And this is targeting very small children, so ages 4 to 7, and it's basically distilling some of the basic ideas of programming into this very appealing, very tactile visual language. So this is an interface where you can create a program that will run, and this is a little wheeled robot that will follow these commands. So moving in different directions, turning, and it's really without actually getting into code and without actually knowing that you're using Arduino, essentially programming it in this very simple way, and a great way to get kids to start thinking about the logic of programming.
Yeah, so actually I have one of these here with me. This is one of the other boards that I've actually got, which, and actually the title here is incorrect. This is actually, no problem. This is the Smart Citizen board, and this is a really cool project from some guys out in Barcelona, where it's just a little board with all these different environmental sensors that you hook up, and it actually connects to it's connected to a repository online where it's pretty much logging data from smart citizens from all over the world and collecting this kind of pretty consistent data from all these people all over the world and mapping it on geolocating all this kind of data about the quality. I mean, everything from temperature, humidity to actually air quality and sound, light, and it's something that's been this product ran maybe about a year ago. The actual boards were received. I received mine about 2.5 months ago. Again, it's not yet set up, but it's just like a really cool kind of citizen science type of project. This is something that this project I think we were really passionate about for many levels. I mean, one that for the few of us who really kind of like electronics, we were just kind of interested in seeing an electronics product package like this as a citizen science project, which is something that we don't see that often, and it's something that we'd like to see more of coming through the site.
said the name was different than when you wrote
Yeah,
it?
it's called Smart Citizen is actually the name of the project because the Bear Touch board is actually the
Sorry,
next.
yeah, a holdover from this other slide. So this is in fact the Bear Touch board, which is another Arduino at Heart project, and this is very cool. Bear Touch makes this interesting conductive paint, and this is a board that integrates with it, so that this is actually little things that were painted on, and they connect to the board to act as triggers. And so it's a way of sort of prototyping without even having to solder, just by drawing and painting your circuits and kind of your interface directly, and a very immediate way to build interaction.
Yeah, no, this is one another board that I backed, but I have not received it yet. But it's really awesome, and I mean the Bear guys have been doing a lot of work with painted circuits, and I mean they even have conductive body paint. But this is kind of their first foray into actually developing a board specifically for use with painted circuits.
And then this is just a really fun one. Again, another Arduino at Heart project. This is a project called Little Robot Friends, and these are very simple beeping and flashing characters that both you can interact with, so they're responsive to light and sound. So depending on how you control those things, they'll respond to you. But also, they talk to each other. So they have different patterns that they'll flash and beep at each other and have little conversations. And it's also something that, in addition to there being a set program, you can tap into it and program it yourself and kind of explore like the most basic form of kind of communicating with a circuit in this way.
Yeah, and I mean it's just really kind of nice how they were able to create something that's so dorky and so cute, and and make it programmable so that you can kind of add your own behavior to it. I think that's.
Yes, so let's see. There is one other project that we're excited about that's actually set to launch. Let's see if it loads. Just a moment.
I know, it's an addiction.
How many projects would you say get backed by Kickstarter staff alone?
Tons. I mean, our guy who's backed the most project on our team has backed 1,500 projects. Yeah.
Even he has his own film festival that he runs in the office for all of the film projects he's backed. So this is a project that's set to launch actually on April Fool's Day, but it is entirely real. And this is an Arduino-based Kickstarter project idea generator. So this is going to, we're certain, to send a ton of traffic to the site. And so this guy, Tim Ellis, he actually made a website that's been up for a while that you click on it and you get yourself an idea for a Kickstarter project. So in this case, a Wi-Fi infrared elastic clock. Definitely can make that with Arduino. Atomic polychromic paper mittens. Sure, why not? We'd approve it. We're really excited that this will have physical form, powered by Arduino, and again, it's going to, I'm sure, triple, quadruple our numbers based on all these project ideas.
Yeah, so I mean, this kind of, that's pretty much it. I think that gives you guys a good sense of just a little bit of the kind of stuff that we see there. I mean, I think the message we want to get across here is that we love Arduino projects on Kickstarter, and so if you have an Arduino project in mind and you're considering, how to bring it to life and how to fund it, definitely think of Kickstarter as a possible approach, and definitely what we recommend is just do some, take a look on our site, and I think you'll see a really big portfolio of projects, and you can see, you definitely can learn a lot from how our platform might be used for that. And now I think we have some time left, and if you guys have any questions, we'll turn it over to you guys.
Yep. Hopefully, as you saw, there's a huge range. So everything from small project with a few hundred backers to thousands of backers. So it's not about always doing big projects.
What's your
Yeah.
definition of successful project?
Well, I mean, I think successful project, we usually just mean that they meet their funding target. So,
Funding target.
yeah, because for every project, they set that funding target, which is, it's an all or nothing model where if you meet your funding target, then you get all the money that's been pledged to your project. If you don't meet your funding target, then you don't get any money, and the backers who backed your project, don't spend anything, and they don't have to. Just kind of, that's a way to make sure that the backers only have to give you money if you're able to get enough money that you can actually bring the project to life. But for us, any project that meets the funding target, we consider successful. I mean, you see some projects that kind of way exceed the funding target, and you see some projects that just squeak by. But I think what we like to see is just, we like to see it, the project will come to life. So
So the developer sets essentially the amount of money that they're looking for?
pretty much, they determine how much money they need. It's based on their understanding of what work they need to do, both from maybe additional design work to actual production work to actual shipping and fulfillment of the. And sometimes they'll do they'll give some rewards that are not directly related to the project from the standpoint they might be a promotional T-shirt or something. And then we always also want to make sure that they include, think through, really well in detail all these kind of little kind of costs that add up. But it's really like, that's something that we don't it's up to the creator to kind of figure that stuff out and figure out that budget, and up to then the backers or prospective backers to kind of inquire and make sure that if they have any, if they don't trust that the creator has thought through that well enough, like it's up to them to not back the project and to not, to make that.
And all of this information is on your website?
Yeah, Kickstarter.com, and I mean you'll find the guidelines. There's a Kickstarter school/handbook where there's some information, and there's a bunch of forums out there as well where you can also get some feedback from actual creators that run projects. So that's another kind of place to look.
So there's the takeaway from those statistics you were showing, that if you have a project and that does incorporate Arduino in some part of your prototyping, you should use that branding aspect to get the most attention for your particular project?
Not necessarily. I mean, I think that was more just to show how there is an active community on Kickstarter that's interested in Arduino projects.
Right.
It's not to say that you should use. Actually, I think it's more. That Arduino community, I think, is more interested in real Arduino projects.
Right.
Like if you just are doing a project that at some point in the past you use Arduino to prototype it, it's something that we're excited about because it's like we like, but it's not something that we're recommending the creator necessarily tout as a way to promote their project. It is something that will often, projects on Kickstarter, the creator does need to talk about how their project was developed.
Yeah.
So often, that's something that will often come up in a lot of projects. But yeah, it was more just to show how the community is.
Yeah.
Do you guys help these people, like putting the campaign together, or?
Minimally. I mean, we're mostly making sure that they're presenting things within our guidelines. We will give advice about how they're presenting things somewhat, but it's most people come to us and they know their product better than we do, and they know kind of what they need to do and kind of what it will take to actually realize this.
Yeah.
Does Kickstarter track the point where the item is shipped or they're done in the project, or just when they're reached the final goal?
I mean, we don't formally track product. I mean, we do usually, once a product finishes funding, the creators provide updates on our site, and most of the times the backers and creators are still talking in the comments section of a project. Yeah. And so we do actually track products where things really start falling apart. We do find out about them, and we do usually reach out to the creator. Ultimately, it's a contract between the creator and the backers. Yeah. We're not officially involved in that contract, but it is something that we care about the community, and we try to kind of grease those wheels so that our big thing is usually backers and creators should communicate. I mean, the fact is, projects on Kickstarter, there is the risk that the project might not be able to be delivered. I think that's you're backing somebody who's trying to bring something to life.
Yeah.
You're not buying a finished product.
Yeah.
And that's a core part of what Kickstarter, of what the platform is about. But we also, want to make sure that that's happening in a healthy way, so that the creators are communicating openly with the backers, and so that if issues are arising, the backer should be finding out about it. And when we see that that's really not happening, we'll try to nudge it a bit. But there's only so much.
But as Julio said, kind of the projects tend to live on on Kickstarter. So this is, for instance, an image from a project update that the ArduSat people sent out, actually showing the satellites deployed and in space. So you often do see the trajectory of the project and kind of understand that it has made it to people through the updates that happen on the Kickstarter page.
How do you classify a project as Arduino at heart? You spoke of one project that was a small display. It was micro:bit or something.
Yeah.
Actually, yeah, there were actually 5 of them that are part of that program. And that's actually a program that Arduino has started, and I'm guessing Massimo will talk about that more.
We don't have an official slot for it, but once he's up, I'm happy to take questions about it. Yeah.
So we were just pointing out that a number of those projects, a number of the projects that have kind of done the Arduino at Heart program have actually chosen to launch through Kickstarter. So there's an interesting connection.
And I think for us, I mean, in terms of that type of thing, we just, when we look at projects, we just try to, because I think we are people who know about Arduino on the team, and we just, when we look at a product, we try to look is this technically representing accurately, how this project relates to an Arduino. So Arduino at Heart is a different thing in the sense that it's a real program. When other projects, it's usually like they're Arduino compatible or something like that, which means that they actually, they use the same one of the chips that are also used in Arduino, and that but that also insinuates that they haven't necessarily gone through the level of testing, for example, or any kind of, they don't have a direct relationship with the Arduino brand as like an Arduino at Heart project would have.
Thank you guys, sir.
Can we take one last question, Tom?
For the projects that didn't get funded,
Yep.
were there any instances where it was a really good idea they missed?
There's clearly a bunch of
feedback, why they missed?
It's hard to say. There's a bunch of great ideas on Kickstarter that don't make it to life, and some of them they just, they're not able, to connect with the right community. They might set their funding goals too high. There is really kind of a large bucket of reasons why a campaign might be a good idea and might not be successful.
But that said, many projects will kind of regroup and try again. So we've had plenty of projects that don't succeed the first time and then do a little bit more work, figure out a little bit more what their needs are, and figure out how they can reduce their budget and come back and succeed. So there's definitely plenty of good stuff that does eventually make it.
Thank you guys.
Thanks.
Hello.
Seems like it was good discussion.
Hello. That's great.
Raw. Okay, so thanks all for coming. We figured we'd give you some proper welcoming remarks. Massimo Banzi, one of our co-founders of Arduino, me, one of the other co-founders. We just wanted to say welcome and thank you for coming today.
Thank you. Thank you.
Take it away.
Okay. So thank you, Tom. So actually, I haven't prepared any presentation with it's no slides, which is good. The only thing I wanted to highlight is this event is important because it's fundamentally an event that's been organized by the community all over the world. So we have something like 400 and something events in different parts of the world. And there's like 120 events in Europe alone, which is interesting. And so I like this idea that we basically told the world, you're using Arduino, you have communities where people are using Arduino and it's changing the way you work, the way you learn. So why don't you get together, which we give everybody an excuse to get together and sort of get to know each other better. And they responded very well. So now we have all these things going on all over the world. It was interesting because when I woke up this morning, my Twitter was already like full of people mentioning us and me, because it started off in China with our friends at Seed Studio. They started sort of the celebration, and then it continued. And now in Europe, I received all these pictures from Italy. We are running one of the other official, let's put it this way, Arduino days in Rome, because we have also at the same time launched the new call for maker for the next Maker Fair in Rome. It's going to be the first week of October. So last year, 35,000 people showed up in Rome for the weekend, which was pretty amazing. And this year, we expect to have at least 50 to 60,000 people. And so, the community around Arduino is increasing a lot every day. And the only thing I can do now is just say this event is made by the community for the community, so it's essentially made by you. So we can only say that when we started working on Arduino, we didn't have any expectation it was going to become this big. We just wanted to make the life of our students easier. So
I also want to say thank you to, first of all, to all of you for coming, but also to some of the other organizations in town. We've got people here from GenSpace, we've got people here from Parsons, we've got people here from Tembu and Space Brew, and it was kind of an experiment this day because all of us in the various schools and hacker spaces and organizations tend to kind of run our own events and on our own shows and so forth. And when Massimo suggested Arduino Day to us, I said, well, let's invite everybody and see who shows up, and see if we could actually do something where we all do it in one space. First time, we got a few. It's a good start. Let's try and do it again. So we're really excited to see everybody here, and hopefully we'll do some more of that as time goes by, and we hope others will too. Mostly today, in terms of today's remarks, should we just open it up to questions?
Yeah, I mean, if we thought we could use a piece of, like a part of the time we have for questions. So if you want to ask questions, we're here. You don't have to. It's fine.
Sure.
It's not mandatory.
Are you guys going to do some work on converting strings to floats? Because that's one of the problems that I've been having recently with.
Oh wow, that's very technical.
Right into the dev forum. Okay.
Yeah, there is some.
There's some libraries for it, but it's really annoying. It takes up a lot of space in the Arduino itself right now.
There is some work happening on the. So there's a mailing list called developers@arduino.cc that you can sign up to, and that's the place where the developers who develop the Arduino itself hang out, and that's like where the hardcore nerdy stuff happens.
Yeah.
And so I read the messages, but I let them sort of play with the code. And
I think it's worth mentioning that our full-time development staff at this point is 2. So we get to things as fast as we can, and it's as a company we're growing, and part of the challenge is to figure out how much of their time goes into maintenance, how much of their time goes into new products and so forth. So hopefully we'll get there on it. But what has happened over the last really year or so since Christian Mallier took over the developers list is through his and Federico Fessore's work and through the issues list on GitHub, they've been squashing a lot more of those issues faster than we have in the past. So make sure it's on there, and yes.
And also so we have seen a lot more contributions. So right now it is much easier for people to just submit a patch, and also because we switched to GitHub, which makes it very easy for people to contribute. So if you send a pull request, at least once a week, Christian looks at all the pull requests and pulls in a lot of them. So I know there's been some discussion about that in order to fix it. The issue now that Arduino starts to have is that since we have a history and we have a number of products that people are using, it becomes more and more complicated to change something without breaking the whole thing.
Yeah.
And every time we have to break something in order to improve life later on, then I have to spend a week with people complaining and like posting, you idiots, what the hell are you doing? All right.
Yeah.
What is the future of the Arduino Internet of Things space? What do you do, and what's your plan? I know we introduced like Ethernet, Arduino, card, and also Wi-Fi one now, but do you want to?
Well, actually, the people were doing Internet of Things with Arduino back in 2007.
No, I know.
So in a way, no. What I'm saying is that we've been doing that kind of stuff before it was cool, as usual, and so we started to. But in our case, it's easy to just take an Arduino and stick a Wi-Fi module to it. Everybody can do that, and in fact, everybody's doing it. But very few people are doing something where once you stick that Wi-Fi module to the Arduino, it then becomes something that you can use, even if you're not a nerd. So our objective is always to try to figure out products which make it very easy for people to enter into a particular space and make it very easy for them. So we spent quite a bit of time working on this Arduino Yun. And we think by combining a small Linux machine with Wi-Fi and an Arduino, but also creating the software that lets the two parts kind of communicate with each other. And also we had this great collaboration with Tembu, which sort of added the ability to to talk to hundreds of different APIs. So we made a tool which really allows you to make a toaster which speaks to Facebook or whatever in 10 minutes, which given that you want to do something like that. So in a way, for me, it's important like this. Also, we're looking at a cheaper and simpler Wi-Fi module. So we are working on a Wi-Fi module.
Fees of the Wi-Fi Bluetooth modules are too expensive to go in this space.
Yeah, that's a problem for us too. I mean, since we're not a silicon manufacturer, we're kind of beholden to what is out there. We're constantly on the search for new ones. We're constantly working with companies who are making them. But until we reach the point where we're a large enough and wealthy enough company that we have a fab house, we're kind of going to work with what's in the market. The other thing we're trying to do, and I think that the Tembu point speaks to this a lot, is there's also a good bit of complexity around being on the internet. And when we started with the microcontroller stuff, we tried to address that complexity. we're trying to do that when we talk about network complexity now too, and that's where Tembu's been very helpful. We hope we're going to continue to do that kind of thing.
That part is outside the Arduino chipset, right?
No, that's not outside of what Arduino is. It's outside the hardware, but Arduino isn't just the chipset.
See, I think one of the issues that we sometimes have when we talk about Arduino is that people tend to focus on the piece of hardware, while Arduino is a whole ecosystem which is made of hardware, software, people, ideas, and all of that. So for example, when we made the GSM module for Arduino, there's lots of GSM modules out there. But we spent an insane amount of time coming up with an agreement with Telefonica, the mobile operator, which puts a SIM card in every board. And we created a very, very simple setup process. So you can, in 5 minutes, you put the SIM card, you're online. So I think Arduino has value in this kind of things where we put together a package which is the hardware, the software, how to use that, and all of that in one single package.
One of the things we're learning, I'll just say this real quick. One of the things we're learning as we go, we are a small company relative to the hardware, the larger ones. And as you know, we've started to work with some of the larger companies. And that's definitely a learning process, both for us and for them. There are moments where we look at each other and go, can we do this together? Oh, gee, we can't, you know. But the fun part about it is figuring that out. What our hope is to try and reach some of those things that you're talking about. But I do think that it's a long-term process. It involves us and those other companies. And the more they hear demand from customers as well, the more we make that happen.
Is there going to be anyone working on a web-based IDE for Arduino? And there's a very specific reason why I'm asking that. There's a lot of people who are being introduced to Chromebooks, and then there's a kind of disconnect between the physical computing accessibility and the kind of low cost of the Chromebook, and kind of trying to get these things kind of working in an educational environment. And I was thinking that it would be really wonderful to have a web-based IDE that could function on a Chromebook and have that program.
What time are you giving the demo?
Actually, we're not going to show that part of it, but I can. The Tembu guys are going to do some of that.
Anyway.
So I can sneak preview it if you want. Yeah, when we do that.
Anyway, so today
Yes.
actually we are gonna show some preview of this new Arduino tri-board, which carries its own IDE inside. So it's an HTML5 based IDE. So the way you program that board is by you hook up the board to the network, and then you point your browser at it, and it's all HTML5, JavaScript, and you can compile. And so
actually,
this is the first item. The idea is that IDE will be then integrated into the website later in the year. So you'll be able to kind of code within the website. And then the plan is that longer term, we will deliver that also as a desktop app. So in a way, we will be able at some point to unify all the development environments under one code base, because also our issue is that, again, we are a small group of people working on it, and so we can't have like 7 different technologies happening. And HTML5 has a lot of promise in terms of how what we can build with it.
So in other words, yes. Yeah.
So on the same lines of questioning, what do you guys think about building an emulator? Like, if you have an Android emulator that exists itself?
So we generally haven't built emulators, and there's a reason for that. It kind of has run counter to our personal teaching philosophy. We have tended to try and teach in a way that it's faster and easier to learn by physically building than by emulating. Now, if somebody else wants to build an emulator, like a few have, great, go for it. That's why we open source this stuff. We haven't put our own resources into it because it kind of runs counter to the way we work personally.
I think he's not looking for emulator, he's looking for some kind of debugger. The problem is like when you compile everything, dump inside the Arduino, you don't know what's going on.
Yeah, let's make sure that's what you're looking for.
So basically my line of questioning was around this whole teaching concept. Right? So if I'm teaching a class of students, say of 30 people, I cannot have, say I'm not able to afford 30 Arduino boards. So if I could have something like an emulator that I could emulate and still demo and ask the students to also try at the same time, and still have a couple of admin tools where they could come in and then push their programs through and test it. But for the basic few projects like just blinking an LED or going through a thermosensor or something like that, we could still have it.
Yeah, I mean, honestly, it's not high on our agenda for the reasons we mentioned. I don't think we would say no if somebody built it, but until we've got the resources.
They have, but they're charging for it. So in a way,
yeah,
it costs less for you to buy a real Arduino.
Yeah.
Even a Chinese copy. I mean.
Are you guys dealing very well with the Chinese copies that are coming out that are very cheap, but at the same time sort of, let's say, just have this brand now where even if somebody is aware that you can get them for basically really cheap because it's made maybe not the same quality, but it seems like the way I see it is people still buy the original Arduino just because I don't know, you have the brand set up very well to the point where there's more of an incentive to buy an actual Arduino, even if it's more expensive than.
You're kind of answering your own question there, yeah.
Yeah, no, that's insane.
Yeah, thanks for the answer.
It is an issue with the people who use our branding and our graphics on their board, because they're obviously trying to deceive people, saying this is an original board, and obviously since they don't need to develop any code, they don't need to maintain the code, they don't do returns. You buy it on eBay, it doesn't work, they say to you, well, come find me. And so in a way there is this problem that one, I think it is a bit of a problem, because it also reflects on us sometimes. Sometimes people show up on the forum and they say, oh, I bought this Arduino, it doesn't work. And then I'm looking at the picture and say, I'm sorry to break your heart, but this is a copy. Yeah. And that one is particularly difficult to do because, they come from countries where kind of trademark protection is kind of like...
Not enforced very well.
Yeah.
No, yeah, it's not something they do. So in a way, slowly some of them are learning and they start to add their own branding to the board and they start to develop their own things. I think it's, slowly will be less of a problem.
Yeah, the ones that are actually doing their own branding, there are a lot of them out there and that are actually quite good, and we're happy to see that happen.
So within the space of larger projects and businesses, I've heard of this concept that they often call the trough of sorrow. Are you guys familiar with this?
No.
So you start a project, you get really excited about it, and then you're excited about it for a little bit, and then at a point you run into an obstacle that makes things difficult, and you almost feel like giving up on the project, or it takes a lot more grit to move through it.
Oh, you mean every third Wednesday?
So I'm wondering if there was a particular point in your guys' process of this project where you kind of had to push past a point where you might have called it quits.
I joke, but I think that actually happens every third Wednesday. No, I mean, it does happen, and you do push past it. You figure out how sometimes they're technical problems, sometimes they're business problems, sometimes they're personal problems. And the one thing we try to, stop me if I'm wrong on any of this, but one thing we try to do is just keep talking and planning and try and keep good communication open. When it comes to the business problems it takes a lot of creative thinking, and it takes a lot of saying, okay, how much of this do we know and how much of this do we need to get some advice on? And in some ways, if you do things, I was going to say if you do things well, but I think the other answer is if you get lucky, you have good friends around who will say, you know what, maybe you want to try this for a while. I don't think there's one answer to that question, but yes, I think it is a common thing. The best answer is keep aware of each other and try and keep some self-awareness. Does that make sense?
Yeah, I think also one of the other issues, another way to look at this is that as you progress with any idea, there's a question of scaling. So every time you add a zero at the end of whatever, it becomes to make that jump becomes very complicated. So at the beginning, you get some random manufacturer to make the first Arduinos, you don't care, you sell them cash to people who need them because you know them personally, and then suddenly you need to send an Arduino to somebody, over the internet, they order it over the internet, you have to set up the whole thing, you need a business that does. So every time you reach another level, the amount of work you need to do to kind of get to that level is a big hurdle that you need to, when we were signing the contract to distribute the Arduinos with Radio Shack. Radio Shack is used to dealing with very, very large companies, and they're tough at negotiating, and their contract is surreal. I saw it is like a Bible. It has things like, it says things like, if you're selling this product in California, Vermont, and South Dakota, and your packaging is made of more than 70% plastic, it needs to be done in a certain way. And there's like sections and sections of this stuff. And you look at it like, what the hell is, why, And so you understand that like classic businesses have got all these kind of layers, and they're like geological layers of stuff that you need to drill through in order to emerge. And so that's one of the problems.
Yeah, I think.
Congratulations on getting through every other.
Thanks.
In regards to you brought up the Radio Shack thing, because I was pretty happy when I actually went to Radio Shack and saw them kind of getting back to this old electronics thing. But I have this fear: is this the golden age? Like, is this a short term? Like you're saying, there's a lot of red tape dealing with them, possibly. Like, how has Radio Shack affected Arduino, and is it going to grow?
Well, in a way, I have to say that when I mention all this red tape and everything else, I think this is stuff that Radio Shack has to deal with in order to be all over the U.S. So this is not something they. I'm sure they would love to give you a contract which is like 10 lines. We'll buy the board, we sell them, thank you very much. And the problem is that when you are all over the US, that's obviously gets complicated. I think in general, the Radio Shack deal was important because it brought Arduino on everywhere in the US. So I read an article somewhere that said that every American is at most, I don't know how many miles away from a Radio Shack. So in a way, potentially, it's a great distribution channel. And I went to a Radio Shack event for resellers, and there was a lot of people from different parts of the US coming saying, oh yeah, now the college next to where I have the shop is now using Arduino, we're gonna buy it. And so you get to talk to the people. So it becomes really granular. And there's a whole section of the market of people that still are not into buying online. They prefer to go to a place where they can talk to a person. So in a way, I think it's when you run a business, at some point you have to hit the retail barrier.
Yeah, I think another part of it though is that, Radio Shack, as you say, they're hitting problems right now too. Anytime you do have those sort of magnitude leaps, you can't stop. It doesn't mean that you can rest and you're done with that now. So we constantly have to say, okay, that's going fine now. What's the next channel we need to look at, or how do we keep the health of that relationship? And also you have to keep in mind that when you make partnerships, you only have so much control over what your partnership is. You do your part of the job as best you can, and you hope that they keep going the way they're going. And if not, you hopefully have other partnerships too.
On the point that Radio Shack is in trouble, and they seem to be having to make some decisions about how much do-it-yourself stuff to include in each of their stores, and some stores will have more, some stores will just be consumer stuff. I wonder if maybe there's no way to know this, but I wonder if putting Arduinos in the stores, because you can't just get an Arduino, you have to get
The rest of the stuff,
components to use with them, if that's influencing them to try to keep as much of that, the big electronic shelves in the stores as much as possible, because you need that.
I think you'd have to ask them. But I mean, that's obviously one of the reasons why we did the starter kit, which has been selling quite nicely. And you hope that they will do that.
On that starter kit, which is a wonderful thing, because we have bought now a number of boards. So far, I think we have 3 Unos, 1 Yun, 4 Unos, a Yun, and a bunch of sensors. So our shields, yeah. But one of the things that we've both been seeing is, depending on the sensors you're buying, there's no documentation, you spend a lot of time trying to get to work, blah, 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 that's fine. But that kit that you guys, we were up and running in no time. Is there something that you could do, perhaps a spin-off, that would allow more of that? Because like the Yun, for example, is trying to get the Wi-Fi working on that was a real pain in the butt. We still didn't succeed on that one yet.
Oh, wow.
The Uno was piece of cake with the Ethernet. That was like 1, 2, 3, boom, done.
Well, one of the things you're getting at is actually gets back to his point about the Internet of Things. So he's an expert in the internet, I know. And so one of the things we're learning as we make more complex products is that you do need to do not just more support, but more explanation. And that, to my mind anyway, and I'm speaking for Tom here rather than the whole company, so tell me when I'm speaking differently, that makes me tend to want to take products slow and thorough.
Right.
But at the same time, I get really excited when I see that there actually has been a good bit of success with the Yun. One of the interesting challenges with the network is no two networks are the same. And I think it makes me feel very good to hear that the starter kit worked, because that says good documentation helps too.
Oh, no.
Right?
I think it's huge.
Cool.
I think it's a huge piece of it, because at least for our experience, he's a mechanical engineer, I'm not, but I'm very, I'm a programmer type, right? So between the two of us, we've been doing a lot of experiments, and that book and the whole kit together just launched us, because you do want immediate feedback. You don't mind playing, but at some point, if it doesn't work and you keep trying and experimenting and it's failing, it's like, okay, I gotta go do something else, and I can't,
Yeah.
But that kit was a very quick success. We were able to get things built, and then once we were able to follow your steps and get things built, then we were like, okay, now let's go do blah, blah, blah. And we started getting our creative juices flowing to be able to expand upon that.
Cool.
But that kit was what kicked it off.
Good to hear.
If you could do more of that when you're doing the Youngs and all the rest of these, that would be really fabulous.
Definitely
because
on the
that
agenda.
is the thing that, because I don't know how much money I've spent so far on this stuff, but it's been about a good amount. And I'm happy to keep doing it, because I love the whole thing. I just love it. Cool. And but please do more of those, the whole package with the documentation, with the kit, with all those pieces, because that is a fabulous thing.
I mean, to touch briefly on the Wi-Fi thing, it's funny because a number of people have said, "Oh, the Uni is great. We love it. It's finally a lot of things are just simple." So clearly, there's as Tom said, no networks are the same, but there is also an inherent problem in the way the Wi-Fi is still quite not very user friendly. Yeah. So. Because the way you configure the Wi-Fi on the Yun is that you press a button, the Yun becomes creates a network. You hook up to that network, you configure your network. So that was the simplest way. But the funny thing is that I have meetings now with like big silicon vendor companies who like billions of dollars. Say, we solved the problem of hooking up a device to the network, and then they show me exactly what the Yun does, but worse, because maybe the interface is really, really weird. It's a classic designed by an engineer web page, type. So this kind of stuff. So the industry itself hasn't really figured out a secure, a safe and simple way to basically say to a device, okay, let's, this is the network in this room, press a button, boom, hook up. Yeah. Because there are some standards, but they have security issues. So, people can kind of get into your network. So, in a way, there are some problems in the industry that the industry is not solving. And so this whole Internet of Things, it's not going to take off until they fix these issues.
Yeah. We should actually stop, because there's another session starting in 2 minutes ago. But thank you guys very much. Thank you for coming, and please enjoy the rest of the day.
Thank you.
And we'll start the next talk very soon.
I have this like really pocket.
Okay, so trying to keep things on schedule here. We apologize for going a little long on the last talk. I'm actually very pleased to have the guys from Tembu here with us. As we mentioned, we've been working very closely with Tembu on the Yuin and on our new tray as well. Although it's still theoretical in their minds, they haven't seen one yet, but they will soon. They've been really instrumental in our thinking about I prefer the phrase connected devices. They've done a great job of making it possible to connect to so many different web services through a common API, programming interface. And then when we started working with them on a partnership, they made it even simpler. So I applaud them because I didn't think it was going to be possible to make it that simple to program an Arduino to connect to the net, and these guys have done it. So let me introduce Vaughn and Tim from Tembu. Thank you, guys.
Thanks, Tom. This is a great introduction. Thanks to NYU ITP and the whole Arduino team and everyone for coming. Also want to say happy birthday, Arduino. Tembu's, we've really loved working with Arduino. We started out doing more like software type stuff and services, but we've always been fans, and it's been incredible working on Arduino hardware. So, as Tom mentioned, I'm Vaughn. This is Tim. We work at Tembu, and I'll give a quick presentation about Tembu, and then we'll do a demo. So I can go to the next slide. So what's Tembu? So Tembu, we've created a unique library in the cloud of over 2,000 programming processes. And basically, if you want to use any of these processes in your code, you can test them out on our website and then generate a code snippet to run that process in over 8 different programming languages. What do these processes do? Well, chiefly they connect to over, you can go to the next slide, to over 100 APIs, such as the ones here. They can also connect you to databases easily, like a MySQL database, and we also have a library of code utilities that make development easier. So you get a lot of benefit from streamlining your code and developing faster. Next. So this past year, we teamed up with Arduino to work on the Arduino Yun. The Yun was the first Arduino with a Linux chip, and also the first Arduino to be internet enabled out of the box. So you don't need a Wi-Fi shield, you don't need an Ethernet shield. And basically our thinking was, we would put the cloud or the Tembu cloud inside this microcontroller device to make it much more powerful, not only more easy to develop and program with, but extend its capabilities. So how did we actually do that? Well, for the Arduino Yun, there's actually a small Tembu client that lives on the Linux chip, and then we have a library that is part of the Arduino IDE, and basically you can use Arduino sketch language to program a Tembu interaction. The bridge library on the Yun talks to the Linux chip. The Linux makes a HTTP request to the Tembu cloud and then runs whatever API interaction you need. And then the Tembu cloud can also do things like pre-parse data for you so that your board doesn't get overloaded with a long API response. So there's a lot of benefits from using the cloud in a microcontroller like this. Just this past week, we extended our compatibility with the wider Arduino family. So we've added support for Arduino Uno, Due, Mega, and other Arduino compatible devices. This was an interesting challenge in the sense that, obviously these boards have been out for years. There's no Tembu client pre-installed on them. So we had to figure out, a new way to make them work, and also to, address the compatibility issues with different types of shields and make everything program easy, because that's what Tembu's goal. Here's a big overview of the Tembu platform. It's like a nice schematic that Tim here actually designed. So when you go on the Timbu website, you can browse all the choreos or choreographies. That's the name for our pre-built processes on the platform. So for hundreds of APIs or databases or code utilities, you can test them out on our platform, or on the website rather, and then generate a code snippet. You put that code snippet, which is a normalized, generally about 5 lines of code, depending, give or take, on whatever language you're using. But for the Arduino Yun, for instance, you take that code snippet, put it in your sketch, then uses the bridge library to talk to the Timbu client on the Linux chip, which then makes HTTP requests to Timbu. The Timbu platform then puts together the longer process and runs that, connects to whatever API or web service you need, and then shoots the data back to the board. So it's an interesting way of sort of virtualizing your code. Next. The flip side, a complement to all of this is not only the technical aspect, but also supremely good documentation. Basically, our goal at Timbu, when we work with Arduino, is to get people, to have a quick win as quickly as possible. And often that happens, setting up your Arduino, connecting it to Timbu, and getting your first API action happening in under 10 minutes, like 5 to 8 minutes, which is really cool and really fast. And so this is just an example of kind of the tutorials and stuff on our website to get you working really quickly with posting to Facebook, interacting with Twitter, sending sensor data to Google spreadsheets to sort of begin, give you the starting point for more advanced projects. Next. So now we'll actually show you the Timbu website, and you'll get a sense of how this whole flow works and how this user experience or developer experience works within the Timbu library. So we have these getting started pages similar to Arduino for all the languages we support. On the left side of the library is this really long tree of all the APIs and other Timbu choreos actions that you can work with. Like for instance, all these utilities. We can show you quickly what it's like to test out an API interaction on the Timbu website. So we can go to, for instance, DuckDuckGo. It's a simple, it's a private web search API. You can type in a query here to see, and test it out on the website. You can see what kind of output the API will give you, so you can get a sense of how to work with that data. And then if you want to incorporate that choreo into your program, you simply have the sample code right here. We have a drop-down menu that'll immediately generate it in any of these languages, and then you just simply copy and paste it right into your code.
Yeah, and so all the languages are accessible here, and something we did different for, so for most of our languages we have short code snippets, but for Arduino and processing we generate complete sketches that you can run immediately.
Cool. And recently in January, we came out with this thing called the device coder, which will generate a complete Arduino sketch for you that will do something like take sensor data and initiate an action like sending an email, sending an SMS, writing to a MySQL database. So you can see, Tim is navigating through here. You can choose, what devices. Right now we have Arduino Yun and then the other Arduino boards. It'll give you a selection of sensor types that you can use for your project, and then the sensor type can trigger an action. So in this instance, we'll use, I guess, a motion sensor to log data to a Google spreadsheet. And
yeah, we have
we'll talk about it.
Yeah, proximity sensor here. And I'm going to demo that in a sec, but first I wanted to just show this new feature. So as a complement to the other sections of the library, we have this, as Fawn said, this device coder feature where you can both kind of generate, so it's building upon generating the entire sketch, so taking in what sort of sensor you're using and what sort of conditions then trigger the call to the API. So, and as Vaughn mentioned, we have, email, phone, SMS, and we're keep adding more there. But for the demo, we're gonna show how to log sensor values into a Google spreadsheet, which is, yeah, pretty useful. So here you can select the pin. So we're going to have pin 6 as the output and to trigger the LED, and analog pin 0 for the input where this is connected to, and put in the name of your spreadsheet, and you can send what kind of value you send out, and we're going to have it trigger whenever you're greater than 400. Okay. So you generate this, and you can download the whole sketch or kind of copy it and paste it into the IDE, and then upload it, which we've already done to this board. So plug in this board. Bring up my spreadsheet. Yeah, I guess. One second while it
Oh yeah.
boots up.
It's loading up. But anyway, basically what will happen is when the proximity sensor, senses a value above that threshold, it then logs it to the Google spreadsheet. And the cool thing about this is not only is this really quick to set up, and you can effectively set this all up without actually writing any code yourself,
Here we go.
generating it on the website.
So the light went off.
So yeah, and basically what's happened is it'll trigger the light to go on, log these data values onto the Google spreadsheet, which sometimes there's a little bit of a lag with the spreadsheet API. And then a cool thing about part of the way that this works is that since so much of this is happening on the Timbu platform, you're actually conserving a lot of RAM on the device. And for example, here with the sketch builder, we save a lot of these inputs or settings that are part of the sketch onto the Timbu platform, so that you can oh yeah, there you go. Now it's grabbing. Awesome. And you can do things like sometimes go onto the Timbu website and change, for instance, what spreadsheet this is going to write values to, or what phone number you want the sensor, the Arduino to call. You can change sort of aspects of it, like
you can
your code like
you
that.
can change it on our site without having to re-upload the sketch to Arduino. So I can change this to, I have another spreadsheet called More Sensor Values, and I'll just change the name of that here and save my inputs. And now, instead of generating here, they'll generate in this spreadsheet without having to re-upload the sketch or change your sketch code at all.
Cool.
And so, yeah, it's capturing the kind of the analog output of the sensor, and then I'm also tracking just how many seconds since the sketch started running. But you could kind of adjust these to anything you want, basically, any type of sensor, and kind of adjust kind of what you're saving, what sort of data you're saving. But just the really cool thing is it makes it so much quicker to just like try something out and see how it works, and then you can kind of customize it and adjust it as you go. And I can show too, I also have this button set up to a Twitter account. So you can see the last one was an hour ago, and when I refresh, there's 6 seconds ago. So I have kind of this sketch hooked up to both spreadsheets and Twitter, and it's pretty easy because I just kind of set up in the sketch the conditions to trigger each of the kind of the code that I copied from our library, and just kind of set up the conditions to trigger them, and then it can trigger kind of whatever API call that you want.
And an interesting thing about
entirely new sketch down to the HTML from the web, or
what's that? Sorry.
can you push an entirely new sketch down into the HTML chip from the web, or
through the IDE?
Yeah, through the not through the Timbu interface.
Not through the Timbu, but through the IDE.
Yeah.
You can, but you can change certain things like on our side, like because we make it so you can save things like credentials, so you could change which Gmail account you're connecting to or which spreadsheet you're connecting to. That you could change on our site offline, but I mean off.
And that's
outside
something
of the
that we
Arduino.
plan to sort of bring out more as we build out the sketch builder, is this sort of idea of being able to reprogram or change activity on the device by making adjustments on the cloud rather than having to actually touch the code on the Arduino, which is a cool way of thinking about reprogramming hardware and also extending, MCU capabilities, since these are in general resource constrained.
Asked about that in the last talk.
Oh, okay. Okay.
Kind of be what they're asking for.
How about more complex sensors? Like simple one is like temperature and it's DT 200 something chip, the tiny one. But it's just like single wire communication instead of like analog to little pulse modulation kind of thing.
So we have a.
Excuse me, can you repeat the question?
Yeah, he was asking about more complex sensors and how we support them, and so we do support several in our device coder. We have multiple sensors, and we also have this generic sensor that you can use as a starting point. But there's definitely some. The more complicated the sensor, there's strange normalization and stuff so we don't have all of that built into here, but this is definitely the starting point to kind of bring in whatever sensor you want and connect it to the APIs.
You write your own code to be able to use that sensor, right?
The more complex ones. Yeah, but we kind of have
I think it's worth mentioning that this came out basically at the end of January, or so it's very new, and in that time we have these sensor types. We just last week added support for a bunch more Arduino boards, and basically we plan to keep an aggressive schedule like that. So
we're
it's
growing
really,
this section a lot. So if anyone has any requests or for anything, send it to Hey at Timbu.
And I think ideally we build it out with different types of like health monitoring sensors and different sensors that are in high demand, adding a more complex array of actions that can be triggered, and then eventually getting to a point where you can think about multiple Arduino devices and programming them. But there's lots more to come.
Yeah, and these save sets of inputs, you can have multiple ones, so you could have kind of different versions of it that you could
Just one I believe like when you change the sensor in this case, more complex ones, you need to actually upload the sketch over and over again. You will not able to like do the same trick on the website. Like imagine that I put just a simple button, right? You upload the sketch, it looks for just the one of the pin 6. But after that I install temperature sensor, it just does some other things, right? And then your sketch is going to be redundant because it's not going to understand.
Yeah, it depends on the type of. Yeah, if you switch from a digital to an analog, then
you need to upload the sketch.
Then you would change that. But yeah, we can. But yeah, definitely it's.
Yeah, we can.
Something we'd like to talk more about.
Talk at the table about like different varieties of what actually needs to change in the sketch versus what needs to change on the cloud. Any other questions? Either.
Is there a limit to the number of calls that you make within the server in terms of is there a daily limit or something? Or it's for developers?
So the question is there a limit to the number of calls you can make to Timbu? So with Timbu, we have basically a generous free plan where you get 1,000 Timbu calls a month, though for students or people doing basically non-commercial projects, we're actually pretty flexible on that. You can email me and we can give you more, or even if you're working on potentially a commercial project, but you're in that testing phase where you just need to run, thousands and thousands of calls and things like that, we can work with that. That's also, it depends. APIs have their own like rate limiting basically. So sometimes if Google only lets you make a certain number of calls, that's another factor to consider. And then beyond that, then we have like paid plans starting at $9 a month, so it's very affordable. Mm-hmm. Yep.
If I understand you correctly, then all this is being run through your websites and through your servers. In other words, it's not even like this code itself is on the YUN, but rather the YUN is parsing this server using this code, and then it's going to your Google accounts, it's going to everything else. Is that correct?
Yeah.
I'm trying to get a better understanding of.
Yeah, basically, so like the Timbu code that you're using is basically
It's not on the hardware, it's on your server.
Exactly. And so for something with like a microcontroller, the idea behind that is that it will save a lot of RAM and enable a lot more capabilities from devices. And it's interesting to think, a lot of these Arduino boards have been out for years, and now we're adding new capabilities. It's like what can happen once you get that one hook into the cloud. There's sort of almost an infinite amount of possibilities there. And I think it's important to think about that when you think about connected hardware. When we have a world where there's going to be potentially thousands of objects, buried in highways or roads or across shipping containers, agricultural fields. These are all going to be things that will need to be flexible and can't be replaced every 2 years like you replace your cell phone. We got to think about how to make connected hardware backwards and forwards compatible in a bunch of different ways. I think we are out of time, but we have a table out there, and I would love to talk to anyone and answer any more questions there.
I want to shower a little bit more praise on Timbu because one of the things that happened in development of the partnership with Arduino is that I kind of yelled at these guys a little bit about how important I think comments are in code. And one of the love things about the device coder is their comments are better than my comments. And I was like, oh, I love you for that. So, yeah, as a teacher, you can actually teach off of their code from the device coder, which is useful. So a couple more minutes, and then we'll see Space Brew. Great. Thank you, guys. Thank you.
I think so.
Okay. So next up, we've got Brett and Julio from Space Brew. Space Brew is a project that originated at the Rockwell Group Labs as a tool for doing exhibit design, lots of various network devices and exhibit design. It has since emerged from Rockwell Group. Both of them are now working in other places, as are many of the other people who worked on it. And it's really become a very useful tool for connecting lots of interactive devices together very quickly. It's a really interesting tool for, well, exactly that. And so I'll let them talk.
Cool. Great. Are we on? Yes? We're good? Okay, cool. So we're going to start, as with anyone, with this quick video that is very confusing, but I think you guys will enjoy it. And this is the Rockwell Group space right around the corner. It is as crazy as it looks. So that's it. I think you guys probably get it, and we'll go from there. So what is Space Brew? I keep hearing people ask that. So this is our long description, but we'll get into some more detail for a little bit. But we like to call it a service and a toolkit for choreographing interactive spaces. So the way that a choreographer sets up a group of dancers or whatever, and says, you go here, you do this, and this is the relationship you're going to have and move through space, is the way we like to think about interactive inputs and outputs. And so what we do is make it really easy to connect different things to each other and connect them very, very quickly, and also disconnect them really quickly, which we'll talk about in a little bit. And we really started from both creating these large-scale interactive installations and having this prototype-driven design effort. We like to learn through making and just make stuff as quickly as possible and hope it's not terrible. If it's not, we use it. And if it is, we just throw it away and make something else. So Space Brew started, I'll talk over this video. It started from a project called Plug and Play that we did as a commission for 01 in San Jose in 2008. And they asked us to project in a building, and we said, sure. And we didn't know what we were going to do, but then we had this idea of using the civic space. So it was actually City Hall in San Jose, and creating different interactive stations that people could plug into and then patch into this projection. So when you yell into a megaphone, or when you jump on hopscotch, when you sit at a picnic table, or when you post to Twitter, Flickr, or Foursquare, or when I think traffic goes by as well. I try to remember them all. It creates one of these interactive blocks, and they all combine into one large projection. And so we built this elaborate system to make all these things happen. We used Arduino, we used XB, we used camera sensing. We had a lot of different scripts running and scraping Twitter and Flickr and things like that. And it was a nightmare to make all these things talk to each other. And everyone was just like, oh, it's great, this fun thing. And I was like, it was so terrible, but it was great when it actually happened. And we said, first of all, we need to make our lives easier. We need to make things that work this way, that we can really quickly patch these things all together. And we want other people to make this kind of work. Like, we don't want to be the only people projecting on buildings. We don't want to be the only people creating interactive spaces. And so we created Space Brew out of this to make these things happen. And this is our, I love making these slides, like a million videos. This is a few things that people have made with it, especially and made with Arduino as well. So a lot of people use it to connect different spaces together. So what actually happens is not only can you connect interactive inputs and outputs, you can connect them over the internet. And so this is, for example, a remote presence tool where you can play with your cat from your office. You can pretend you're in this meeting, but really you're doing something much more important, playing with your cat. And people use it for a lot of different types of projects. This is a beautiful art piece from the Copenhagen Institute of Interaction Design, where you can kind of understand someone's approach upstairs through these stepper motors that make this kind of interactive sound installation. And we're also working right now with the design technology program at the New School, and here are a couple interactive projects from that, where you can water a flower and water someone else's flower over the internet, or when you run out of your beer, someone can finally know about that across the space and bring you a new one, trying to solve the most important problems in the world. And so what actually is happening behind the scenes here is we have Space Brew running. It's a script that runs on a server, and then we have clients. And so a client can be on an Arduino, it can be on the internet, it can be in open frameworks, it can be in some toolkit we haven't imagined yet, but it'll work hopefully as well. And when it connects, it says, these are the kind of things I can talk about, and these are the kind of things that I can listen to. And Space Brew can help you build logical relationships between those two. And so if you have a thing where, say, this is the volume of my phone, and this is an LED, and this LED says, well, I can listen to R, G, and B and change colors. Space Brew, I can patch those two things together and say, now, if I want the volume of my phone to control a color, all I do is actually go to this web interface, which we'll show you in a second, and patch those two things together. So just as a quick technical detail, that thing is all happening over WebSockets. So anything that can connect to a network via WebSockets and is formatted in JSON. We're working on some more protocols, but that's how it works at the moment. And this is the sort of switchboard I was talking about. So when everything connects, it shows up in this beautiful online tool, and you can see we're actually patching these things together. So each sort of line here is a different client, and maybe it's an input, maybe it's an output. We can kind of look at this list and see what's happening, and then the server says, okay, let's patch these two things together. These two things can talk to each other, and once you make all these relationships, suddenly you have an interactive installation. It's just that easy, finally. One of the big pieces we have right now is this way to make these things talk to each other. How do you know that the volume can control an LED, but it can't control the switch in this room to turn the lights on and off? We have 3 different built-in types that are Boolean, range, and string. And what they do is make it easier to automatically route these things together. So you can say true or false or on and off, range for a number, and string for text. So this could be Twitter, this could be, again, volume, and then a switch. And we really, so when we built that plug-and-play project, we made stuff in every single toolkit you could imagine, because some things are better than others at doing different things. It's much easier, obviously, to prototype in physical space with Arduino, but I wanted to make some high-res projection graphics, so we used open frameworks. So we've created different libraries for every toolkit we can think of at the moment to allow Space Brew to patch these two things together and let these toolkits do what they're good at, basically. And so, when I want something in the web, I use JavaScript. When I want different types of projection, I use open frameworks, and so on and so forth. And so some people might be wondering why. I hope I've answered that a little bit, but that is the main thing, is creating this way to glue all these parts together. And we had this big focus at the start, real-time communication, letting things happen very, very fast. So when I jump on a hopscotch, I immediately see this projection, this explosion happening. And then the main thing we want to talk about is this idea of the low floor and high ceiling. So all of these libraries are ready for you, and once you start off, you're already in the network, you're already ready to connect to someone else and interact with someone else. And so you can have prototypes really, really quickly happen. Cool, I'm trying to pass. Sorry, I can just ramble, and Julia's just like, Brad. But yeah, and I'll let Julia talk about Space Brew and Arduino a little bit.
Yeah, we use Arduino is one of the core technologies that we've been using with Space Brew since the beginning, which is even why when we have the Space Brew range, a range is actually just a 10-bit value, like an Arduino analog value from an Arduino sensor. So primarily, the way we had first connected Arduinos to Space Brew was just through processing. So for the first 6 months we were using Space Brew, all of our Arduino examples, and anytime we wanted to connect to the physical world, we had to have the Arduino connected to a computer, and we would have that connected to processing via serial port, and then have processing actually do the communication with the Space Brew server. But a lot has evolved since then. Now we actually have a Yun library and an Ethernet library. The Ethernet library works both with an Ethernet Arduino or with an Arduino with an Ethernet shield. And it's pretty robust. It works pretty well. The Yun library is a newer library. It does work quite well as well. We're still debugging it a little bit just because we don't have as many users using that library. So we're still, they're still finding some bugs in that and kind of working to resolve them. I actually was encountering one earlier today when I was doing some demos out there. And so today we have a bunch of Arduino demos actually set up just outside this room. So later on what we suggest is if you want to come over, we can definitely show you a few examples of Arduino's connected to Space Brew to control lights, control printers, and but again, the demos that we have out there are just really kind of simple demos, just kind of showing something not in context. I think the real kind of magic using Space Brew is when you're kind of really kind of embed this into more of an interactive installation where it's technology is hidden and it's really about your experience. And Space Brew is just kind of the glue behind the scenes that is helping you kind of join all these disparate parts and choreograph them.
Yeah, and so what we have right now is a set for all these different frameworks, different libraries to kind of get up and running. And then our website, which should be on more slides, is spacebrew.cc. And if you go there, you'll see we're building up our kind of tutorials and examples. But what we want to have is a lot of these sort of small parts that you can start a project with. So you'll see out there we have an LED bar that just changes color. But that can go to represent a lot of different types of outputs. And if we have this thing where we can build up these different examples of inputs and outputs and have the way to connect them and build a relationship with each other, we're trying to build this community of all these different pieces that people can kind of build interactive installations from. So that's kind of our roadmap at the moment is, A, obviously doing a lot more testing and things like that, but B, trying to build up this sort of cookbook of examples and say, okay, what can you actually make with Space Brew? What is the bare bones of an interactive installation? And how can we make this sort of toolkit for people to use to really quickly get up and running and prototype and move things back and forth.
And before we get to questions, the only thing I want to say is, Space Brew is an open source project. Right now, it's really just kind of kept by a bunch of us who kind of do this outside of work. I mean, we might use it a little bit in projects that we do at work, but primarily it's like a project that we do as a passion project after hours. It was born at the Rockwell Group at a point in time that we could devote actual work hours to it, which is a very nice luxury to have for an open source project. But at this point, there's a few of us here in New York, a few of us out in the West Coast, and then there's some people spattered, some in Europe, that do projects with it and contribute back to it. So I mean, if anybody's interested in using Space Brew, again, it's totally open source. You can kind of take the code, do whatever you want with it, use however you want with it. What we just ask is if you build something cool, that you'd be willing to see what you can kind of give back to the community so that other people can continue to build cool stuff with it.
Is it?
I'll switch to the questions.
Is it limited to like one-to-one, or can you say like multiple ins and like
you can connect multiple to multiples.
Do some logic based on those things.
That's a great question. Yeah, I mean, I think it's very much up to you. I'll pull up the admin interface a little bit bigger so people can see it. But this is really what it looks like. And you can see all the things that we actually have out there. And so really you can do a one-to-one and you can actually route to yourself, which is what's happening right here. But you can make as many connections as you want. And you can also do this via the command line if that's your style. Basically, you can create as many sort of relationships as you want. And right now we actually have, so this is running, so that the server runs, so it can run either on your computer or over the internet. And right now we have a free, sort of slow, but sort of fast one running that people can prototype with called sandbox.spacer.cc. So all the examples you'll see online, you can connect to immediately and prototype your own stuff over the internet. And then we have tutorials about how to set up your own server to run over the internet or run on your computer. And so this is what's happening live right now. So it's a mix of our students' projects and the things that are running out in the main space at the moment. you guys have any other questions? I know we went through that very quickly, but we can show you. Do you want to show your quick thing?
I think it's better to
We'll
just
do it
kinda
out there. Just kidding,
out
guys.
there. We have a bunch of stuff over there.
Yeah, definitely. But it's yeah.
That's
I don't
about
know.
it.
Any other questions in general?
All right.
Thank you.
Cool. Here, we'll show you this as the keep in touch slide is very important. Yeah, it's very small, but spacebrew.cc, and you can follow Julio and I on the internet and all that stuff. And then we have a Tumblr of student work at MFA. It's very, very long. mfadt-spacebrew.tumblr.com is the current student project. We're working on, if you go follow the blog at spacebrew.cc, we're working on putting together more kind of hackathons where people get together, make some stuff with Spacebrew. We're there just in case you were to ever have a problem, which who knows if that could happen. But yeah.
Anthony?
I'm curious about where like Spacebrew and Tembu kind of overlap in terms of like the connectivity, because there seem to be some things that are kind of in common, and I'm wondering about if you imagine in your own way, like how you might bridge those two projects into one very powerful. I mean, it's powerful already, but something that would just be like, you know.
We were 100% hoping someone would ask that question. So first of all, we love Tembu, and we actually use Tembu all the time. And it's really exciting because for us, we're trying to build a more general toolkit that's very much focused on real-time data and very, very generic. And so we use Tembu, and we have a bunch of examples of using Tembu to bring that data into Spacebrew. So for us, Tembu is the same as if you build something that's like a mic, for example. So I say I want to build an application that connects to a microphone and sends that sound level to Spacebrew. We say, okay, instead we're building an application that connects to this range of APIs and sends that data as text or as a number or as a true or false, whether or not there's a new tweet or something like that. And so it's this way to bring this huge world of input data, and then Spacebrew lets you connect it to a physical output or a projection output and all these different types of ways. So yeah, we use Tembu all the time. And there's a good example online that Julio has as well.
So is Spacebrew basically saying, create like a data primitive and give it to me, and then I will figure out how to route it? It's sort of a router for these primitives. I didn't see any kind of application logic inside. Maybe things went by fast, so maybe I missed that, or maybe it isn't there.
No, it's intentionally not there. So it very much is a router, and I should mention as well, I mean, we have those three basic types, but it's just JSON, and so we supply custom types as well. So you can say you just give it a name and you say, oh, I'm sending person, and that's a size and a position, and you can pack a larger data object rather than just the sort of primitives.
So I can either throw a primitive or an object into the system, and then it's Spacebrew's job to say where that primitive or object goes, translate it, I guess.
I mean, and the one thing it doesn't do, it doesn't do, like, of course, if you're doing a custom type, it will only let you send that data to another app that accepts that same custom type. So if I'm I say this app can provide data can publish data of type person, and another app can subscribe to data of type person. Spacebrew will link those two, but it's not going to check whether that data is really of type person. It will never know what a data of type person is. It will just allow you to link two apps that say that they can deal with of that data type person.
Right. And therefore, it's not doing like aggregations or transformations or anything.
No, it's not.
Take it and pass it.
If you wanted to do that kind of thing, you'd have to actually do it in a way where you kind of pass it to one app that does some processing and then sends that process data out. Like we're trying to keep the server as bare bones as possible. And we've had conversations, should we have some level of ability to transform even just very simple things like numbers, floats to ints, or like process even at that very basic level. And at this point we decided against it. Yeah, it is.
Most people have done a good job at making those kind of services where it takes an input and then spits it out as something else, or translates it or multiplies it, and it's really quick to make those kind of things. And then so if you have it in this sort of Spacebrew realm, you can build that translation up and you can swap it up for different things too. So if you have this sort of filter model that you have one thing publishing something and then you just swap out whatever that filter is, because you can just patch and reroute those things whenever you want.
So very much a patch panel kind of.
Yeah.
You could have called it patch day, except for
exactly, and we're real time. Real time is important. Definitely.
This is a pub sub, right? A
Yeah.
publication sub.
Yep.
Okay. So is it similar to the MQTT? Is it similar to the, it's an open source platform also, messaging, queue, telephony, something?
I don't know that platform, so I mean, but if
So, all right, let me ask the question differently. Okay, so this pub sub, all right, so you have a server that is going to support requests coming in, okay? So for each client that wants to publish that I have, this available, this information, right? So it's going to go to the broker, which is essentially sitting on your server.
Yep.
So each client would also have to link that library, right? They'd have to be
Correct.
compatible.
Yep. So right now it's a separate piece that you bundle into your application. So if it's in JavaScript, it's just an external piece that you include, and then all of that logic is handled for you. So you just tell the library, okay, these are the types I publish and the names of the different pieces.
We have it already for the Arduino as well. That's kind of what I'm getting at. So the
Yes.
Arduino client, you would be able to link that in the schedules.
Yep. So that's two, and that's the different ways. So and there's two different ways, or three different ways, as Julia said it. So there's one that you can do with the Ethernet library, and that just sort of builds logic on top of the Ethernet library, or you can do it directly with the Arduino Yun as well. And so,
I mean, I think the only limitation with most Arduinos is more like if you're trying to do something very text heavy, as you know, if Arduinos are not great for doing a lot of text processing. But yeah, with the Ethernet library and with the Yun library, you can.
You might essentially shoot over commands back and forth.
Yeah, you could definitely do that. And look at the Ethernet and the Yun libraries are the two quickest way where without like connecting a computer at all, just having a standalone Arduino connected to the to a network, being able to kind of connect to Space Brew.
And MQTT is a protocol, not a platform.
Oh,
so it's a way of it's a standardized method of communication, but it does not accomplish anything in itself.
But there are limitations.
There are lots of
yeah, there's lots of implementations.
Yeah, it's being used a lot of Internet of Things, which are much less real time oriented than what's going on here.
Yeah, so
use it for real time. Anyway, I just want to make the distinctions.
and in that case, I mean, really, like WebSockets is what we're using as our protocol. So that's the sort of, instead of MQTT, WebSockets is the piece that we're built off of, basically.
Like WebSocket is like TCP level. It's like it's
Right. That's another way. Yeah, there's another level of abstraction there.
Set of standard like you remember the old like XML-based SOAP standards, packages and everything. You send it, and then again subscription and whatever publisher model, and then it's a data byte. You can actually pop everything inside it and get it.
Okay.
So based on standards, it's a protocol.
Okay.
We make
Website.
like protocols.
Gotcha.
Awesome. Yours lightweight than MQTT.
We're trying to be as lightweight as humanly possible without breaking anything.
And what, obviously your focus is real time. What kind of throughput do you have? Like, what kind of benchmarks can you use?
That's a common question, and we don't have a real benchmark yet. Because I mean, a lot of it depends on how you're running it. I mean, our target is always trying to send a particle system at 60 frames per second. So if we say like 1,000 floats or more at 60 frames per second is our dream. And so running on a local server, you can get pretty close to that. We've gotten very, very close to that running locally. If you're running over the internet, there's a lot of variables there, and so that's the main piece. It depends how fast your cloud server is and how fast your internet is and things like that. For sending most of the data, it's very, very, very fast because we're sending such small packets. It's just JSON, and we're looking at WebSocket supports binary as well, and so that would be that's the kind of goal for this year is supporting that to make things a little bit faster. But yeah, if you're running on your own computer and you have the gigabit Ethernet set up, you can get pretty fast.
One question. I believe it's like you use the TCP for the WebSockets, right? Have you ever tried UDP? Because low latency systems, they usually use the UDP protocol instead of TCP protocol. And as I see this art kind of project, the data. I mean, if I use the data, it's not that critical. So UDP doesn't have like that much check and much
FSA, have you ever tried it?
We've done separate systems. We never tried to run Space Brew on UDP basically, but you know, we've used UDP. We did one piece that we were syncing 180 laptops together as and syncing a particle system, and in that case, we were not worried about if we miss one frame or something like that.
And I think also, I mean, the primary use of Space Brew was really as a prototyping tool. I mean, I think we've used it in a few production environments, and we'd like to use it more. But so, like, being able to really quickly and easily be able to link stuff. I mean, which is why we selected WebSockets, because then it allowed us to just kind of have a bunch of different type of platforms or frameworks that we could link together really quickly and link and unlink. But we do find that sometimes when we are kind of getting ready to do that final installation, like we'll build the initial proof of concepts, great, we test some interaction things, great, but then when we're scaling it, sometimes we need to find a more customized solution like UDP or some other kind of way to link things so that they provide the performance that we want at the final installation. I mean, in a dream world, we wouldn't have to, we would do it all Space Brew, but to be honest, like,
yeah, that's what we're building towards is the dream, yeah.
So.
Cool.
All right.
If you have more questions, we love answering questions.
All right.
Cool. Well, we're right around the corner. If you guys want to see demos and have more specific questions, please feel free. Thank you.
Thank you.
T-shirt that Jody is going to be wearing the comic one. And when I looked in here, I saw you here, I said, is Jody the lady that has glasses? I talked to her 4 times already. So.
He was just about to come in here. Oh, I'll just wait. Okay, there we go. So folks, next up on our parade here, we've got Jody Culkin. Jody is a dear friend and one of the first physical computing teachers at ITP. She's now on faculty at BMCC, and she is also a very talented artist in many different media. One of those media happens to be comic books. And what she's done a really great job of the last couple of years is writing instructional material for her classes and for the rest of the world using comics. It's a really interesting and novel approach to writing instruction and teaching around technology, because we're so used to seeing stuff that's kind of dry and boring, and her stuff is just gorgeous. You want to keep reading it so you learn more from it. Also, she happens to be a brilliant artist, so.
Well, thank you very much, Tom. Hello, everybody. I think Tom is exaggerating my comics expertise. But what I'd like to talk about today is just a little bit about using comics to teach technology, different approaches I've used. There's sort of a history of this too. You know, I'm not certainly the first person to do this. And I want to talk a little bit about, some of the people who've used comics to explain technical processes, science, concepts and whatever. This is a definition of comics from Scott McCloud, his book, Understanding Comics, that came out back in 1993. His definition of comics, I like to kind of, cut it down to this: images and sequence to convey information. I mean, that's the part of comics that I'm really interested in, in terms of using it with technology. There's lots of other images and sequences that, convey information. you know, the airline safety card, which is obviously not a comic, and of course, you know, mysterious, enigmatic, you know, handouts you get when you buy something from IKEA that are really confusing. But this does have like word balloons. Back in 1951, Will Eisner, who was kind of an early pioneer of comics in like many, many ways, he started a company called American Visuals Corporation that was designed to like use comics to convey information, you know. His first big project was Preventative Maintenance Monthly that, you know, kind of came out of his experience working in the military in World War II. This magazine explained how to do all different kinds of maintenance procedures and things from like how to start a stalled engine to you know, taking apart a cook stove and cleaning it and guns and whatever. He used a lot of different techniques. Like he had this character Joe Dope, so he used straight up comics, you know, kind of strong narration, you know, characters you might identify with. But he also used photographs, he used like diagrams, and it's got like a lot of text, you know, as well. It wasn't all images. Kind of jumping forward a little bit, I'm kind of jumping all over the place with this. Larry Gonick started in the 70s doing cartoon guides to sort of just about everything. He did one for genetics, he did it for physics, he did it for, I think, statistics, I believe, too. And he also did a strip in Discover magazine about different mathematical and scientific concepts. This one's about neural networks. And this is a little bit off track, but not totally. In 1999, Ira Glass of This American Life did a comic with cartoonist Jessica Abel that was, how do you do a radio show? You know, it had all the technical information, you know, about where you put the mic, blah, blah, blah. And I think probably you guys may all be familiar with How-Toons, which started in, I believe, 2004. You know, this was sort of a team of scientists and cartoonists, and I think Ingrid Dragota is actually a toy designer. They are kind of how-tos for kids. They're projects based on science and engineering concepts. Their projects have been, they're on Instructables. They were also in Make for a long time, and they've been collected into books. The projects are all based on things that you'd have lying around the house. So if you were a kid, you know, you could like make this project or learn this concept with whatever, you know, you might have lying around. And this is a project done by Adafruit, Lemore Freed and Lady Ada, and Philip Taroni did it in 2008. It's a comic called Citizen Engineer. This particular one was about SIM card hacking. I get the feeling this may have been an idea to do a comic based on a bunch of kits that they sell at Adafruit. I'm not sure how many they did. Comics like sort of take forever, you know, so I think oftentimes people have these ideas and sometimes maybe they do one, you know, but it breaks it down. I thought it was nice how they broke down the process. You know, you got it when you bought the kit, but it's also available, you know, online. And Scott McCloud did this comic that Google used to introduce the Chrome browser back in 2008. It really explained the processes of a modern browser and multi-threading and all this stuff. Really, he didn't write it, but he kind of used metaphors and analogies to really explain how a browser worked. Kind of different than Will Eisner, who really, you know, kind of walked you through everything with a character. And this is just another project. there's these series of manga guides to many, many, many different science and mathematical concepts. They were, written in Japan, and No Starch Press publishes them here. This one's the one to Manga Guide to Electricity. Some of you guys might be familiar with this comic. This is like an 8-page comic that was created in 2011. Soldering is easy. It's got a Creative Commons license. It really kind of breaks down soldering with images, very simple. It's all black and white, and text, to kind of get you started with understanding how to solder. And this is another Adafruit project. E is for electronics. It's a coloring book, the ABCs of electronics. And now we're getting to me. I think comics are really perfect for explaining technology because the way the words underline the meaning of the pictures and the pictures underline the meaning of the words is really unique. And I think you can show stuff a couple different ways. So it helps people, particularly kind of like what we call visual learners, I think it's just helpful. I kind of became a little bit obsessed with comics because my husband writes about the publishing industry, and I go to a lot of comic book conventions. And I thought, wow, I can use comics to explain binary notation, which I find really, really interesting. But my students used to look at me like eyes glazed over, like totally, So I was trying to figure out a visual way of explaining this. And it's also a sequential way of explaining it. And this was like my first attempt at a comic. And then I did a comic about Arduino. Like Tom said, I taught physical computing here, and I went to ITP and did a lot of physical computing when I was here. Because I was a sculptor, it made a lot of sense for me. And what I learned on was the basic stamp. Some of you may remember that. The basic stamp, I also used to program PIC chips and BX24, and when I came, and I'd sort of gotten away a little bit from physical computing. I had bought an Arduino and fooled around with it a little bit, but by 2010, when I started really using it again, the platform was super robust and it was great, and I was so happy to think I would never have to buy another basic stamp again or whatever. That I thought, this would be great. Somebody should do a comic about Arduino. And I thought, oh, I guess I'll do a comic about Arduino. I wanted to make it very clear about certain certain concepts that were basic to, doing physical computing. And I really tried to boil it down. The first thing I wanted to boil down was the language, because I've said, oh yeah, I'm working on an open source electronics prototyping platform, and I see everybody, like people go, probably not the people in this room, but a lot of other people, you put them off immediately just with the language. So I was like, let's break down the language, because once you break it down, it's not hard to understand at all. And I also talked, I wanted to do a little bit about a little bit of basic electronics theory, what's Ohm's law, voltage, current, resistance, because I think it's important to understand those concepts. And I'm not going to show the whole comic, I just have a few things. I talked about inputs and outputs, and also another important thing that you always talk about with physical computing is, difference between analog and digital information. So I kind of went over all that stuff first, and then, walked you through downloading the IDE and setting up, getting ready to program, and of course, how to do the wiring, And I did basic digital and analog circuits. Actually, when I started doing this, I thought it would be about 5 pages, and it turned out to be like 15, And I still think probably there's some stuff I could have explained a little bit more. You know, working with, when I did this comic, Tom was very supportive of this comic. He was great, and it got a lot of attention, which was great, because he put it on the Arduino site, and from there it went on quite a few technology sites, and it's been translated into about 10 languages. You know, I did it as a Creative Commons project, because I really saw it as a project to sort of give to the Arduino world, you know. As a result of this, Tom, also through Tom, I met some of the people from Maker Media, and I worked on a project with Gareth Branwyn, who was then the editorial director of Make, for a breadboarding workshop, which they were sort of prototyping at World Maker Faire in 2012. And I did a couple kind of one-page comics. There's a lot of information on this comic. Which is, you know, how to use a breadboard. And then we also did a page that was like a step-by-step, you know, how to build a particular circuit, which was the circuit that they were, you know, using as part of this, workshop. And I also, I thought it would be helpful too to just have, you know, the schematic with like a real annotation of what the board actually looks like, because I think for beginners, that jump between schematic and board is not always so obvious, you know. I'm working with Make still on a manual for, they're doing a kit that will have 10 different analog circuits, you know, that are meant to help you learn how to use a breadboard. And this is the second iteration. I think it's more clear. But I'm working with Sean Reagan from Make, who's done a lot of the writing for this. And it has sort of an introduction just to how to use a breadboard. And it also has, for the circuits, you know, part list. And for many of them, really a step-by-step layout that shows both how the board develops and also how the schematic changes. You know, and then what it looks like at the end. Oh, it's got a glossary too, you know. I think you can never give people too much information. You know, I teach a lot of web development, you know, introductory web programming, a little, you know, using APIs and stuff. And this is something I'm working on myself. I want to do kind of an HTML5 three-part thing, you know, basic HTML, CSS, and JavaScript, you know, and kind of pull them all together. Again, I think for me, you know, I always want to write all over my students' code, but of course I can't because it's on the screen. But I can write all over my comics to explain, you know, why you put this there and whatever. It's, you know, you can give them the code, but you can also give them a lot more information visually. I also think comics are great for documentation. You know, as makers and people who build stuff, you know, we're always documenting everything. You know, blogs and photographs, and I think it makes it really powerful to put them into a narrative form of some type. Drawing every single thing you did might be, you know, like a little bit time consuming, but I think you can take the pictures you've got and put them into a narrative form. This is something I worked on that ITP has a open source laser cutter here that started as a project for ITP summer camp in 2012. And you know, I worked on that project and it kind of got, sort of finished it off more or less with Eric Hagan, who really kind of took it over, who was a resident researcher at the time. But I decided, the project was started by a couple of ITP grads. The Laser Saw itself is an open source project that was originally a Kickstarter project. Adi Wagenicht and Stefan Heckenberger. You know, I took my pictures and just sort of put them into a narrative form, you know. So instead of having endless blog posts, you know, I tried to turn it into a story of some type, you know. You know, they comics with photos are kind of classically called, fumettis. Just one last thing, I use Adobe Illustrator mostly. I use the Adobe Creative Suite. I'm used to Illustrator, and I like using Vector. It's great. But there's lots of free stuff out there. This is, maybe you guys all know this, but I do think it's great to know what the open source tools are out there, software for making graphics. Inkscape is a great open source vector program, and free, very lively community of active users, so it keeps getting better. And GIMP is kind of like open source Photoshop. Same thing, lots of users, keeps getting better. This isn't open source. This is Comic Life, which I think costs about $30. It's I love drawing my little rectangles, in Illustrator, but not everybody really wants to do that. Comic Life comes with all kinds of templates and stuff like that. So if you don't want to draw your own word balloons and rectangles and whatever, it also integrates, particularly if you're thinking of doing something like a fumetti, the photo comic, it integrates very nicely with iPhoto. And, Fritzing is also, I think, a great tool. I mean, obviously, it's a great tool for working out your circuits and switching from your breadboard view to your schematic view and all that. But it's also, I think, a great tool because you can output images, so you could really show how you're building a circuit, sequentially without having to draw, all those little, holes in the breadboard. And I think that's about it. I put a bunch of links here. I put a bunch of links, both, for comics and also for, software, and also a little bit about comics and education. Obviously, this isn't too helpful for you unless you're taking the pictures now, but I will put it on my site. It's a little bit fat. I've got to get the size down of the presentation. And I'll put a blog post. And I have put it on, on Google Docs now, if you can. I guess that was a little small. So, now I've run through my presentation. Questions?
Is Comic Life free?
No, it's not. It's not. Comic Life costs $29. It's the one, What?
It's not that expensive, okay.
No, it's pretty cheap. But I mean, it would be nice if it were free, but it's not, Yes?
Where could you find the Arduino comic?
Oh, it's on my site.
It actually shows up when you do a Google search.
Yeah, if you do a Google search for Jody Culkin, this was my moment of fame. So it comes up really fast, So, and it's been great. It's been used by lots of schools and lots of hacker spaces and stuff. And I love seeing it in Greek. It makes me really happy. Yeah. Any other questions? Oh, I guess that's it. Thank you guys all so much. Thank you for coming.
Thumbs up. like I'll put together 60 slides. That's
Yeah, I know. But you know, it was fun. It did go.
Clip it wherever you find the spot.
Thank you. Thank you, Tom. It was really fun.
You don't have time to do it. Somewhere, or when you sit down, feel free to sit down now. You can just kind of just lay on. Or you just get up. Okay.
Yes, but I really. Do you think I did that? See, I still think free camp.
You know, Dan has extended that time.
I know he said that, but I don't really. I don't like to push Dan.
Is that all right?
Yeah, but it's
Okay.
your job.
Good.
It's your job. I'm like.
Yeah, we're good for streaming.
I know he said that. I said it to him. Calvin may take a while.
Oh, yeah. Yeah.
It really did.
And let's face it,
The thing about
other
Calvin
people don't bring smiles.
Calvin is Calvin loves ITP. Loves ITP. That's great.
You know, it's always Yep, go right ahead.
It's a little weird that I'm to my back.
Yeah, but that's okay. You won't notice after a while. All right, I'm going to go drum the bushes a little bit. I'll do that. And we'll do it again.
Boost me up out there. I want people.
We'll be back in just a second, please. So folks, next up on the list, we've got Raquel Hussein. Raquel is showing us a project that she built that is a device for the detection of epilepsy that uses Arduino as a controller in it. And she's also going to talk a little bit about how it led to her understanding of how to do this. So take it away, Raquel.
Yes. Just a slight correction. I built my own circuit board. I didn't use Arduino as my controller, but without Arduino, I wouldn't be where I'm at. So the title of my project is Application of a Wireless Electrical Device for the Detection of Epilepsy. But before I get into my project, I'll talk a little bit about myself. So a little bit about me. I currently work at the Brooklyn College Community Partnership at Brooklyn College, where I'm planning to expand their science program. And in doing so, I hope to introduce Arduino to more students, high school students, middle school students. I also work at the Translational Neuroengineering Lab, where I performed my research. And it's at the Polytechnic Institute of NYU, which I actually had the logo in the beginning. And beyond that, I would like to become a professor because I have a passion for teaching. And I really want to help the next generation of scientists, engineers. So one of my dream goals is to become a professor and run a lab and to have high school students, undergrads, graduate students, PhD students, fellows, all working together collaboratively on research so we can build a better future for ourselves. Oh, and the picture, one of my favorite pictures, I was a chess champion when I was younger, and this is just one picture that just stood out with me. I love chess and I love cats too, so yes. So, while I was in the lab, and this was back in June of 2013, I was sitting in my lab meeting, and I was reading this paper, as somebody was presenting on it. This company called NeuroVista, they did a study where they used an implantable device to detect pre-seizure states. And what they did was they did a brain surgery, they put the device in, and whenever there was a pre-seizure state, a person would be alerted through a beeping light. And it worked. This was the first study that proved that epilepsy detection could be done internally. However, see, I like to be new, so I decided to ask the question, is it possible for me to do what NeuroVista did? Is it possible for me to detect these pre-seizure states using an external device? So the idea is novel because it's the first attempt at doing an external detection for seizures. So in June, I started writing my research plan, and in July, I began doing my research, at least rather the building of my circuit boards. I began building this device using two programs. I started with Allegro and at Altium. They're both circuit board builders. So on the circuit board, and I know it's not so big, but on the circuit board, there are four main component systems. The first is the biosignal acquisition. The second, the analog to digital conversion. The third, and I put this a little out of order, the power regulation. And the fourth is the Bluetooth connectivity. The biosignal acquisition basically means getting our neural signals from our head to the circuit board. So how can we get these raw signals? We use electrodes, EEG electrodes. So I worked with two universities other than Poly. I worked with RWTH Aachen in Germany and University of Chicago to design a fashionable EEG cap that can just be put on, the circuit board placed in, and it's everyday use. And so what it does is the electrode takes up this neural information, these neural EEG waves, and that information goes through the wires onto this board to these golden pins, to the female end of the golden pins. And so that is my biosignal acquisition. Then it goes to the analog to digital chip that I have here. It changes that raw neural information into something graphable, something usable. And that raw neural information, which is now something graphable, is then sent to the Bluetooth connectivity device. However, and I can't neglect to say about the power regulation. Power regulation is something very important when it comes to medical devices. Medical devices need to be safe. So on the circuit board, there are three ways of actually stopping the circuit board and doing debugging to testing whether there's enough voltage, whether there's too much voltage. So I took careful consideration when building the circuit board, especially for human use. There are filtration systems, and there's also a debug for researchers. And the final system is through the step-up regulator, which is a part of the power regulation system, which maintains the board at 3 volts. And in October, I have my final version, which is great. The Bluetooth modulator, the Bluetooth modulation and everything, that works using a specific chip made by Panasonic. Panasonic designed it, and I use it in my board. It works on Bluetooth 4.0, meaning that it's secure. And so we have all the information going to this Bluetooth chip. And then that information is then sent to an iOS application, which I also designed. The iOS application was written in C++ and then C, Objective-C, forgive me. And I used MATLAB to originally write my algorithms, and then I refined them further. So both of my algorithms, which I name line length and high frequency oscillation, they worked simultaneously to provide an accurate seizure prediction. So these algorithms are important in that they are the only way we can do this detection. So without proper working algorithms, we can't do these detections. But beyond that, I had to learn how to use resistors, use capacitors, use all of these microcomponents, how they work together. I had to learn how to do that somewhere. I had to have a beginning. Every superhero scientist has to have a beginning. So, my beginnings, yes. The backstory. My first experience with Arduino was last summer. During my junior year, I took a class in Arduino with the intention to teach middle school students. Now, that was great. However, what was bad about it was that when teaching my middle school students, I actually had high school students enter, college students. So I was teaching all different levels of students. And it was my first time ever teaching, so. It was my first time dealing with schematics, the schematic diagrams necessary to build circuit boards. It was my first time dealing with microcomponents, such as resistors, capacitors, inductors. I didn't know anything about those things other than the basic things that you learn in physics, you know, about farads and ohms, but I didn't see the actual application until I learned about Arduino. Without Arduino, I wouldn't have made it this far. I wouldn't have been able to do this project. I wouldn't have discovered my passion for the things I loved. I would have never discovered that I enjoy teaching. So beyond that, I also experienced frustration because I was so passionate about it. Now, this project would not have been possible without Arduino. In that, if I didn't learn about Arduino, I wouldn't have been able to make my device, because I wouldn't have had the basis Arduino gave me. Arduino for me was Super Scientist 101. It was my crash course in how to do engineering, microengineering at that. Now, the reason I made my presentation really short is because I know that a lot of people want to talk about the whole detection of epilepsy more, but my presentation was supposed to be on Arduino specifically. So I'm going to leave it up to the audience to ask me questions based on that. Yes?
Could you walk through like a case study of the epileptic person who is wearing your device and like, you know, what happens? Like, what are the signals that are picked up that are unique, and how is it predicted?
Can I use the? Okay. Is there an eraser so I can just erase the? Okay. So I have a marker. Okay. So I'm just going to draw a basic EEG graph. This is going to be one that involves a seizure. Our measurements are volts, microvolts actually, over time, which will be in seconds. So we start with the basic EEG waves. Those are heart waves, forgive me. We have basic waves, normal waves. Now this is our normal set. And again, this is just for explanation purposes that I'm doing it like this. And again, remember, normally EEG waves are actually very close together. So I've just pulled it out a bit so that you can see what these waves look like. When a person is in a pre-seizure state, they have a spike in these waves. So there's like a large spike, a large spike, a large spike, depending on who the patient is. Then what happens is that the spikes go back to normal for some time, for approximately about 5 minutes to an hour. That's the average. And then the person goes into their epileptic state. So that's generally how an EEG wave would work, essentially, at least the seizure waves. So the pre-seizure state occurs approximately five minutes to 60 minutes before a seizure. My prediction, so using my using the application I wrote, it can do predictions in about 2 minutes after, approximately 2 minutes after the pre-seizure state, after the state, approximately 2 minutes. I've tested this using MATLAB, my algorithms, and about 2 minutes after the pre-seizure state. So that gives a person 3 minutes to 58 minutes to figure out what to do. So the point of the device is that it's therapeutic and diagnostic. Diagnostic in that it tells you that you're about to have a seizure. And then furthermore, therapeutic in that the patient can take their medicine to mitigate it. And studies have shown that over time, if a patient takes their medicine before the seizure, the likelihood of seizures actually decreases. The reason research into seizure detection is so important is because 1 out of 10 people in the world and 1 out of 26 Americans will have a seizure at some point in their life. Epilepsy is the 3rd most common neurological disorder in the United States. Those are some pretty high statistics. Any other questions?
Do you have a picture of the shower cap or the cap?
I would show, but because I'm working on a patent right now, just for the sake of keeping it. But it's similar to EEG caps, but it is it's a fashionable cap. Essentially, it's like a knitted cap. Think of like a tight-fitting knitted cap. Yes. Any other questions?
Did you collaborate with a neurologist or somebody to do these studies, or did you just do your own research?
I worked with the Polytechnic Institute of NYU, where I worked with the Department of Electrical Engineering, and we also had, so we didn't test on people, that's the only thing. We didn't test on people because that requires a lot of paperwork. And again, this project is very new in that I only finished the circuit board last year in October of 2013. And the application, I'd been writing it up over the time, so I didn't finish my application until about February. What's also great about, and something I should mention in terms of validity for the research, the average packet drop rate, meaning the amount of packets we get back. So this is testing how viable the neural signal is. was 0.1% over 100 tests. So with 100 tests, and this is testing at different frequencies, different amplitudes, different distances, 0.1%. And we also included impedance tests as well, forgive me.
What do you mean by different distances?
So testing from 10 feet away from the device to 30 feet away from the device. The furthest we ever went was 30 feet, which is a pretty good distance. Just in case if you're not holding your phone, you want to go to the fridge, you want to use the bathroom. Yes.
So 2 questions. The precursor,
The pre-state, yes.
whatever you call it, how many of them do they happen?
It depends on the individual. So, but generally it's about maybe 4 or 5 of them. It's about 4. So they. Oh! I thought you were talking about the spikes. Forgive me.
I'm talking about how many times will you get a precursor
A chance,
before the
right.
actual?
Maybe once or twice. Once or twice for that.
What are you planning to do with all this?
My research.
Are you starting a company?
No, I actually would like to continue doing research. I have future applications planned. One is specifically for communication purposes. So people who have amyotrophic lateral sclerosis, it would be a great way for people who are paralyzed to communicate. It's using neural information again. I was thinking about actually increasing the size of the circuit board and making a portable cap that researchers in hospitals can use. So it has a full set of electrodes in it. There's no wires. It's easy on, easy off. It'll reduce hospital wait times tremendously.
So if somebody wanted to commercialize this, what would they have to do with you?
Well, they'd have to give me their email and talk to me and, work with me. I mean, I'm very open. I put my email right there. And I'm pretty sure the 500,000 people, hello everybody, out there have my email now. So you guys can feel free to email me whenever you want about, my project. I would love to answer more questions. I mean, if you guys have any questions, just email me and I'm available. I check my email every day. Any questions? I love questions. Anything? Give me more questions. Yes?
I want to know how sensitive it is to sense the
states?
Yes.
Again, approximately 2 minutes after the 2 minutes is the average time after the pre-seizure state occurs that detection happens. So it's fairly sensitive, but it's not so sensitive that if you drop it, it'll break or it'll mess anything up. The circuit board is pretty sturdy as well as the cap.
When people, they are not sleeping, but...
Right.
Yeah.
I understand. So in order to deal with that, that's why I use 2 algorithms. And I'm actually working on implementing a 3rd algorithm within my program. The first algorithm checks to see if there's an abnormal behavior state. So if it's some abnormal spiking, it'll check for that. The second algorithm actually checks the amount of spikes within the abnormal set. That's what certifies whether it's a pre-seizure state. Because pre-seizure states follow a 3 to 5 spike pattern, generally. So if there's a 3 to 5 spike pattern, and these spike patterns follow the outline of what a pre-seizure state looks like, then we can certainly say that this person is in a pre-seizure state. Yes.
So you're sending this information to a server, I'm assuming, right? Because MATLAB's not going to fit on a chip.
Oh, no. So I wrote my own iOS application, and the circuit board hooks up to the iOS application, and it sends it directly to the iOS application.
So where is the algorithm processing taking place?
On the application, on the iOS application itself. The MATLAB testing that I did was only to make sure whether the algorithms worked, and then I implemented it within the application. Yes.
The cap is working on the batteries.
Yes. So the cap works on this. It works from the battery of the circuit board, and what's interesting about it, because I really wanted to make it a low-cost, highly efficient device. It runs on one AAA battery, and it can run nearly 2 days on one AAA battery.
How do you know batteries run out? How do you know when it's dropped out? Counting on it to give you always.
So it'll send you an alert when you're so I programmed it so that it would send you an alert whenever the battery is too low, because the circuit board itself needs 3 volts to run. So if there's ever a point where the circuit board runs below 3 volts, an alert will be sent to the phone. So this is one of the means of for helping the patient, keeping safe patient protocols, you know.
So any malfunction in the chip will give you an alert?
Yes, there'll be an alert on the device that you're using. Did you have a question?
Yes. So is your end goal to have the app that's like something that you can purchase, or to have the cap that's something that you can purchase, or are you looking to make it more like DIY? This is how you can protect your.
For a project like this, DIY wouldn't be the best option because it's dealing with people, and so it would be under the terms of medical devices. That shouldn't be something that you DIY. But I would make it so that the cap is something that you can purchase. The application would be free. All the programming would be free. You can take it as you please. Just purchase the cap and put it on. Yeah. There's a lot of different ways. I was thinking perhaps for DIY, one thing that could be done is you could program the circuit board yourself. So it would still have the EEG detection, but you can use that EEG information for other processes, which would be something cool for DIY. Any other questions? Again, I love questions. Questions are great. Okay. So, yes?
What other symptoms can these waves predict?
So I work specifically with epilepsy, but with any sort of conditions that involve EEG waves, we can write algorithms to detect them and then just use them with the application. So just implement the algorithm within the application. So I work specifically again with epilepsy, so I would have to do more research into it for different diseases of a neurological nature. Again, I would also like to work well with ALS. Communication. So the circuit board can be used in several different applications because it's essentially a wireless transmitter for biosignals. So, oh, and something I should mention before I go. I'm just a high school student. Yes, I'm a high school senior. I go to Midwood. Yeah. I just thought it'd be something interesting to mention afterwards. Yeah. Do you guys have any other questions, or is that it? That's it. If anybody wants to talk to me afterwards, I'll be here outside if you want to talk to me privately or personally about anything. Yes. Thank you, everybody.
The other is, you're also utilizing these ways to bring control. I don't know if you saw that. They're doing that kind of stuff too. So it's not only just what, capturing and doing the analysis, but they're trying to, there's a wheelchair demo on the internet.
Right, where you can use your brain waves. I mean, I'm working on an application right now for neuroprosthetics to control actual limbs.
Yeah, that'd be very cool.
Yeah, that's one cool application.
Do you know you're going to have to FDA?
I know, it's killing me right now.
High school student, oh my God, that's so impressive.
All the paperwork is killing me. I have so much paperwork because it's a medical device and everything.
Yeah.
It's like IRBs, IEPOCs, God, you name it.
But that's very impressive.
Thank
Congratulations
you so much.
and best of luck.
Yeah, Shop Labs, right? BCI 2000. I use them for a lot of what I do, particularly because they're written in C, and I love that they're written in C. I mean, it's great. I've been integrating a lot of my stuff with them.
my algorithms, my Objective-C coding is actually different in that I wrote my own libraries for the Objective-C. Because Objective-C actually, for iOS, they don't have good Bluetooth 4.0 code. So I had to write my own libraries in order to use it. Of course, Apple's been giving me a big mess, because when you write your own stuff, so they're like perusing through all my stuff.
Are you targeting specific frequency range, or is it just the entire range of frequencies?
It's the entire range of frequency. The reason being because depending on what type of seizures you have, they can be at different ranges. So, but every seizure state follows specific patterns, and that's what these algorithm checks. It checks the specific patterns.
And did you, there was mostly testing, subjects. What did you use? Diagnose with epilepsy, or did you use maybe isolated various movement disorders, test for
I use reported data. So I took data, like I had drug-resistant focal seizures, parietal seizures, all occipital seizures, neocortical seizures, all different types of seizures, so that my detection system would be a good function. I tested with as many seizure different data as I could get, as many as I could get. It was a lot of testing. Like I was sitting at my computer for like hours on testing, running out of days.
I'm working on a single electrode EEG device.
Oh, that'd be awesome.
Portable for just to do ambient sound, creating a loop of ambient sound in and generating ambient sound out.
Something that's interesting that I'm working on is checking deafness within babies. As babies, they can't raise their hand. Like, raise your left hand, baby. No. So, to actually testing their neural information, it involves using 2 electrodes. And something similar, using a looping system. It's pretty cool. Thank you so much. Market. Great. Thank you so much. Where do you want to go to college? I can't afford to go out of state right now. I was looking for that. I did a short presentation because I wanted more questions than anything.
Next week, company gets set up.
Cool. I'll clean the website. Just give me a second. Well, I'm looking to actually go to a cheaper because again, I want to so if I go to then I go for a nice ride.
Well, so online we watch.
What's the IP address on this one?
128.
I really want to go to Grace Hopper, and I need some responsibility.
188. The first 3 I have memorized. The last one is always the one that's right.
Well, you look like you know.
Which part do you want me to focus on? Actually, this area
Yeah, it won't be like
just like that. Why don't you put that actually here? Let's do this.
Okay, yeah.
Because that doesn't need to be, you don't need to control that right? Worst case scenario, if it goes to sleep, just do this.
Alright, I've got mics for whoever is talking. Just jam that in your pocket and then put this to your collar.
Because we've got another one way to go.
Do you have a card or something? I don't have your name in the thing. I want to put your names up there. Did you have yours? I think I spelled your name wrong.
I think I may have spelled it.
Yeah, okay, alright. It gives them some play. So I'll just take the extra E out. Alright, I'll put you up on the thing. This is just right back to your collar. Thanks.
You know what that is? I think it's the... This is the one that's up.
This is going to be controlled. Well, I can put the... First, let me show you that. That's one view we'll be showing. And also the small head. Yeah.
You good? Ready to go? Yeah. So, it's being responsible for perspective
I'm sure there's a lot of names on there.
So folks, next up on the agenda, we've got Oliver and the folks from GenSpace here. For those of you who don't know GenSpace, GenSpace is a biotech enthusiast community center, I guess we could call it that.
Yeah.
Sometimes we call it a biohacker space.
Community Biotech Lab also.
Community Biotech Lab. I'm going to go with that. But they've been around for quite a while here. I'm going to steal my glasses too. In Brooklyn, and doing some really amazing work around biotech education and biotech projects. And so we're very happy to have them here showing WebPong. Thank you.
Cool. Thank you. So yeah, thanks for having me here. I'm here with our team, Keith Comito and Sarah Chuka, and Narit Barshai, who's another co-founder of GenSpace, sitting in the audience recording. So we have a device out that we're hopefully going to roll out on Kickstarter that we call BioArcade. Sometimes we call it WetPong, sometimes Biotic Games. So we've got a demo here, but I want to talk a little bit about the space that we started a few years ago. GenSpace, this community biotechnology laboratory that's right here in Brooklyn. So just grab the 2-3 train, 4-5 train, go out to Fort Greene area, and it's an open community biotech lab, one of the first of its kind in the world. So it's a biohacker space. So a lot of you here are hackers, so you have workshops that you can go to and use a variety of tools and build things, build objects, usually electronic objects, or code things. We do things similar, but we code basically life. That's what we do at the lab. So our focus is biotechnology and synthetic biology. So we basically have a hackerspace with tools available to everyone to come in and use them to work on a project of their own devising. So these are just some screenshots from the GenSpace lab. We've been in operation for a couple of years now. So what are we approaching our 3rd year anniversary? 4th year anniversary? No, not 5. 5? 2000. Well, we opened the doors in December of 2010, so, to the public, yeah. So we're building up things up until that point. So you can become a member, so it's pretty low key. This is what people thought of when we first said we're going to open up a biohacker space. People were like, what are you going to do there? And that's what they saw. But that's not what we do. Maybe this project eventually. But we work with microbes, so basically small organisms. So we work with, so we have microbes on this microcontroller apparatus here. We work with bacteria, we work with protists, paramecia, we work with plants. So we're a biosafety level 1 laboratory. So what that means is that everything that we do in a lab, you can do in a high school. It's that safety level. So all the organisms we work with, you can essentially eat them. Nothing's going to happen to you. But we do genetic engineering. So we teach, we have projects at the lab, at the space, where people could do genetic engineering projects. And really, a space like this has come of age at this point. So we've had electronic hacker spaces. People have been hacking things, the proverbial garage where Steve Jobs and Wozniak built their PC back in the 70s. You had to supply a source of cheap electronic parts that are available, and you can build these devices and code them relatively inexpensively. And that sort of started to mature around the 70s. Biotech, the kind of the irony about biotech, it's actually one of the oldest technologies of humankind. Rob Carlson he's a biotechnology analyst, called biology, said biology is technology. And all the foods that we eat right now, if we go to stores and we get our heirloom tomatoes, all the organic stuff that we get, that's not natural. You're not going to find a big juicy tomato out in the wild, or a big corn cob. That's been bred selectively globally for the past 10 to 12,000 years by humankind, by basically selecting traits that you like. All the animals, all the plants, that's been selectively bred for traits that we enjoy. And it's only until very recently, and by very recently I mean within like my lifetime practically, the early 70s, that we were able to understand how to use enzymes and other little tools from nature and basically rewire the componentry, the circuits, the genetic circuits at that level, and produce traits at a very in a more defined way, rather than letting random mutations just make some jackpot mutant that we like and then breeding it over millennia. We can speed that up into a span of months and years rather than thousands of years. And that technology is just accelerating, and now it's become cheaper and cheaper and more available, to the point that we're at a stage now that I kind of roughly would say that the electronic hacker revolution was in the 70s. These tools are now filtering out into laboratory spaces, unconventional spaces, and allowing people to utilize them in projects that are not what you would expect when you think of biotech. When people think biotech, most applications you think of are biomedical applications. Certainly that was one of the first few products that hit the market, was recombinant insulin. But now this technology is enabling people to do things with it that are outside of the field of biomedicine, and applications that just you didn't even think of. And I'll go over some of these applications. So this is a screenshot from our lab. This is one kind of component. There's a class taking place here. I'm like the only person not wearing a lab coat. I just can't get used to wearing lab coats. But this is the lab that we built, basically repurposed materials. Alatar is the building owner, is a super cool guy, and this is all old restaurant shelving. So we essentially built this lab from scratch over a period of time and made it accessible to anybody who wants to use it. And we stocked it with equipment that we had people donated, but also that we found on eBay. So I just got a screenshot of, this has already been sold, it's from 2012, but a PCR machine for $99.99. And this is sort of like the heart of most molecular biolabs. It's a machine that's basically an amplification device for DNA. So you make millions of copies of DNA. And that's sort of the reason you need to make many copies of DNA is it's the source material for all our projects. So when you go on TV and you see a CSI episode where they identify a criminal from one hair sample, they can't do that unless they amplify that DNA or make millions of copies of it, so they have enough to work with. So you kind of feed your stuff through this type of machine with specialized enzymes. And this stuff was worth, this device here that's now 99 bucks, it was $10,000 when it first hit the market ages ago in 1995. So now, the cost has dropped dramatically. Sequencing costs have dropped dramatically. When you wanted to synthesize DNA a long time ago, eons ago in biotech history, 5 years ago, 10 years ago, you had to do it in your own lab with the DNA synthesizers. So you had to hire a lab tech to work on this machine using nasty organic chemical compounds, and they'd have to know what they're doing, and it took them months and months to learn how to use it, and not every lab can afford it. But now there's companies that are outsourcing these technologies. So if you want a sequence of DNA made, you essentially go on your laptop, design your source code, sort of know what you're doing, so any kind of string of A's, T's, G's, and C's you want to design, and 1,000 nucleotides will run you about $150. So a company will then literally FedEx it back to you, right? So a lot of this stuff is outsourced. So we have a lab where you can then take these components and reassemble them to your own devising and make a new, what we call a device, but in this case a genetic device that can be uploaded into an organism and have it do something. So we've got students coming in, student programs. We have courses, so we offer a synthetic biology course, so a couple of classes. Students can basically, it's a workshop. You come in and you design something, you build it, and a few weeks later you have your bacteria that's doing something. So all the steps are basically taught. And none of this would be possible if the DNA wasn't modular. All the source code out there, the way evolution has worked, all our sequences are modularizable. We can essentially take sections and basically define them in hierarchical functions and recombine them. So that's why you can take something from bacteria, copy it, and have it repurposed and work in a higher organism, or vice versa backwards. Human recombinant insulin that is identical to human proteins that is injected into humans around the world that saves them from diabetes is produced in E. coli, in big vats, in big fermentation vessels, using human genetic source code that's been copied in a PCR machine. So we teach people basically these key techniques, things like transformation, where you take this genetic information and then basically chemically plug it in, put it back into the bacteria. So this is from a Google workshop. So these are some Google engineers that are just got, I guess, tired of programming code and decided to now work with microbes. And they're shaking a petri dish there, putting some of their DNA, not their DNA, but you could put your DNA in there if you wanted to, putting in another source code into the E. coli, streaking it out, and then later basically looking at the phenotypes. So this is just some samples of some projects we had going on in the lab. So a lot of you have probably heard of GFP, or green fluorescence protein. It was one of these first reporter genes that was cloned from a fluorescent jellyfish. It's used very commonly in biotechnology because it's a harmless protein. It's very small. The source code for it is about 750 letters, so it's a very small piece of DNA to be synthesized. You could get a company to synthesize it for you for about 70 bucks. or you can clone it yourself out of a jellyfish. Luciferase, which glows in the dark, that's basically a gene or a set of genes from a number of organisms, fireflies being one of them. Violacin, it's a number of genes that basically synthesizes a small biochemical compound that produces this purple pigment, red fluorescence protein from sea coral. So all of this stuff can be basically interconverted, exchanged from one organism to another. And you can do a lot of nifty things with it. So we also have workshops for children where they get to paint with these genetically modified organisms, and that looks pretty cool. You know, that's, you know, and you can do really, really sophisticated things with it. So I just want to touch on a few of these applications that are happening now. You know, insulin is one protein that happened in the 70s, saving a lot of lives. Things are getting much more sophisticated where people are now wanting to take entire pathways of many genes and basically string them together and put them from take them from one organism like a plant and put it into something like yeast that you brew beer. So instead of fermenting, producing ethanol, you can produce a more complex molecule, something like artemisinic acid, which is the #1 antimalarial compound. And this is a lot easier to get yeast to produce this grams of this in a fermentation vessel than basically having, you know, many tens of thousands of acres of this plant that you then have to harvest and then use, you know, organic solvents to extract the artemisinin from the plant, so on and so forth. And artemisinic acid is relatively simple. I mean, there's plants out there that are going extinct but have life-saving compounds. So how do you prevent those plants from basically being clear-cut out of existence for a valuable small molecule? Well, you can essentially, you know, really what's valuable to the economic market is not the whole plant per se, but that pathway that's making that drug molecule. So by cloning that, you can get around that whole issue and essentially have it produced in a fermentation vessel. So all of these technologies that we teach can apply to a sophisticated approach like this. So that's manipulating the genetic code. You can also read it. So the two go hand in hand. The technologies to read the code also go hand in hand with being able to adjust it or manipulate it. So applications of that are obviously vast. One type of application is genetic testing. So I don't know here, who's like submitted their DNA sample, spit in a tube and send it out to 23andMe or one of these like, or Genographic or one of these companies that will read it for you. Wow, nobody, one person, two, three. Yeah, there's a bit of controversy with 23andMe and the FDA because, you know, the FDA recently ruled that, you know, unless you have a doctor's permission, you're not qualified as a citizen to look at your own genetic sequence for medical information. So, you know, that was kind of a real weird ruling, but they're cracking down on that supposedly for the protection of the consumer. But you know, it's probably because they were charging really cheap for it, like 99 bucks. But we teach how to do genetic testing in the lab itself. You can analyze your own DNA in our lab, and it's a very straightforward approach. And we teach all the methods, and we have a class where people basically come in, swab their own DNA. You don't send it out anywhere. You actually do the processing in the lab itself. You extract your genomic DNA. So you've got all those billions of letters floating in a tube. You lyse the tubes. And then after you lyse the tubes and you run this PCR reaction to amplify as much DNA as you need, we're looking at one discrete location. Here's a student loading it on a gel to do the analysis. And you get this band pattern, and this band pattern basically tells you the sizes of DNA at one particular location that's embedded in all the billions of letters of your genetic code. And this one particular workshop that we looked at lets you know whether or not you have a natural resistance or immunity to the HIV virus. So there's a small percentage of people that when they have this mutation, and these doublets here are people that have this mutation. It's this little band here, and these are normal people. It's normal, right? This one here is, I think that's a doublet too. There's one, it's rare to get like just one of these. So 1% of the Northern European population has that. So that was a pretty nifty thing. So you can learn how to do this, and you can analyze yourself, and instead of paying a big corporation $4,000 to find out whether or not you're predisposed to some illness, you can do it for 40 bucks in a lab and analyze it yourself. And best of all, learn how to do it, you know, from scratch and apply this, you know, your knowledge to any bit of your code and read it. And it's really grown outside the confines of just a few individuals. This is a snapshot from 2010. For the past 4 years, I've been mentoring a team. Now it's kind of filtered out into the community biotech spectrum where we're at. So Dr. Ellen Jorgensen, who's also a co-founder and the executive director of GenSpace, she's running a team out of GenSpace where we have a group of individuals participating in a competition going on now for the 10th anniversary called iGEM, International Genetically Engineered Machines Competition. It's basically like a biotech boot camp for students. It started at colleges, and now it's high school students, and essentially happens all through summer, and people get teams together and they try to build some kind of object using genetic engineering, kind of like you would get together, have a competition to code something and come up with like some kind of awesome code or some sort of electronic gadget or robot at the end of 2-3 months. In this case, it would be a new life form. So, and there's quite a few successful teams out there. So this is just two slides I have of a project we did in 2010 with the Harvard iGEM team. This was, we called it the iGarden. This was basically a box. All the components are real. They're just in freezers. We never asked the USDA for permission to sell this, but it would give basically the capabilities for small farmers to compete with Monsanto, for example. So they could produce their own genetically engineered crops, and then raised a whole bunch of other social and philosophical and legal issues, right? So that's one cool thing about iGEM, is that you get to raise all these issues and really confront people with it, because this is now entering the market in directions that are not just biomedical, but biomaterials, for example. New types of materials that are produced from genetically engineered microbes, new types of biopolymers, having microbes produce nylon, for example. Who knows, maybe a bamboo that's incorporates spider silk proteins that has higher tensile strength. So applications that you normally don't think of when you think of biotech. So we'll be seeing more of these types of applications and products hitting the market, and I think the more people that are aware of it and know how this technology is applied, so you could make rational decisions rather than have a knee-jerk reaction that this is all bad or all good. All technology, I think it's obvious to most people here that tech savvy is a double-edged sword, dual purpose. We've all heard these terms, but biotech so far has done, it's not just my opinion, but more good than harm. And if you want to believe it or not believe it, at least know how the technology is being used and applied, and you can come in and actually do it yourself hands-on and see what it's all about. So that's basically what our space is all about. So you can then become a member and just come in and use the facility. That kind of leads into this project that we have here. We were inspired by a lab over at Caltech. Ingmar Riedel-Cruz, he's a physicist, and he was working on something called biotic games. And this is actually an old observation. I wanted to find out, well, when was this noticed that paramecia, basically little critters that live in pond water, respond to electric fields? And I think the earliest paper I found was from 1890. And there are a couple more in the 1940s, but it was an observation. Then now people were like, well, can we play a game with this stuff? So it turns out that you can have microbes essentially respond to polarity gradients. So what we have here is essentially an electric field, and we wanted to have a project that can incorporate both biology and programming and also electronics all at once, because at GenSpace all of our projects tend to focus on really biotech heavy, and we have a lot of people coming into our space that have a stronger background in programming and electronics, coming from that community that's more mature and that kind of hacker space. So this is a cool project in that we can incorporate kind of the strengths of people coming from many different directions and sort of focus on one project. So taking a cue from Dr. Cruz's lab, we basically wanted to have an open source version of this. So this has gone through some iterations over. I was shocked that our workshop was in 2012. I thought it was like, yeah, we must have done this like 6 months ago. And I was like, well, wait, it's been 2 years. And this was our first iteration. It was a workshop taught by Geva Patz, who's an engineer, an electrical engineer, and Ellen Jorgensen invited him, and they brainstormed a project where they can essentially take a webcam and an Arduino and code it, and essentially this little platform here, it's laser cut with pencil leads as electrodes, and build a little platform where you can put your microbes and focus on it, and then essentially alter the polarity of this grid and have all the microbes swarm towards the negative, right? So that's all that was happening, is that they were just swarming towards the negative gradient. And that's GaveUpAds giving a talk. So this is our space, Gen Space. So everybody's here hunkered over, soldering their boards together and making their device. And that's the lab, the glass lab you saw earlier in the background. So really have a mixed use facility here. And if you really want to find out how this early iteration was done, you can go to making.do paramecium, where there's online basically instructions on how to make this. And Gava talks more about all sorts of other interfaces you can hook up with this paramecium game. I think he made a mind control version of this as well. So instead of a joystick, you can hook up one of those, I don't know what you call it. Emotive headset, right? And then you could train yourself to regulate the polarity and use your mind to control the microbes. So this has been going through several iterations, and this is the last iteration we had, Maker Faire UK, and now we've moved on to hooking it up to an Arduino. And Keith here, so Sarah coded the Arduino, and Keith, who's an app developer, designed this kind of really ace system with own custom music theme to it as well. This is us at the World Science Festival. Here's somebody really intrigued by what's going on the screen. And they're controlling, she's controlling basically the microbes. And this is the kind of screenshot from the Paramecia arcade. Keith, I think you have the high score for now. And this is our latest iteration, which we're going to do a demo of. So basically, instead of just looking at the Paramecia all bare naked swimming around, we have an overlay here, some tracking software that Keith would be happy to tell you all the technical nitty gritty behind it. Basically converts them into these white blobs that swim around on your iPhone, so it's an iOS application. And overlaid is an augmented reality screen for the Paramecia with these little rings, which you can code to be anything. And they're just like a real-life Pac-Man. They'll swim through the centers of these rings, and when they take up a certain ratio or volume of that center, that ring is gobbled up by the Paramecia, and you have a certain time limit in which to do this game. So that's basically the Wet Pong Bio Arcade version 1, and we'll probably come up with some other game versions as time rolls on and as we kind of try to push it out into Kickstarter land and get everybody interested. So that's the box I designed. So points to anybody who can tell which game I lifted this off of and what the Zaxxon, exactly, Zaxxon font. So thank you very much, and that's my talk. And we have a demo here of the game. And Narit? Yeah, we're going to show it with the camera. So how do we do it? Turn this on? No. Yeah. No. How do I do this? All right, I'll turn your phone on. 4444. I don't know how to switch the camera. Oh, switch the browser? Is it this one?
Yeah. So just pull up to the back here you go.
Oh, here it is. All right, awesome. So let me see. So let me get out of here. Let me go to the original. Oops, it was right next to the camera. See if the critters are still here. No, got to put some. So we'll make a little artificial pond here. So that's where they live right here, and the iPhone is on this big heat sink. And thank you. And now you can get these Paramecia from a pond, but you can also get it ordered from Carolina Biological. So they're pretty safe. If you ever dove into a pond and swallowed a bunch of water, you just ate tens of millions of Paramecia. So they're pretty much everywhere. They're ubiquitous. So let's see if we can see some of these. So there's a kernel in here where they like to nibble on. So if you kind of go around there, it's like their hangout. Let's see if we pick. Oh, there they go. So you can see them swimming around. All these little things that look like grains of rice are Paramecia. And let's see if this is. Oops, I got to plug this in. So I got to hook this up to power up the Arduino and get a current going in there. Perhaps. Let's see if this. So I think the power's on. Yeah. So let's see if they go. So they're going in one direction. And let's see if they'll turn around. So now they're turning around. Okay, guys, go back in the other direction. There you go. Back in the other direction. Back and forth. Now go right. Okay, go up. All right. Now go back. Okay, they're going towards me. All right. So it's like a stampede of paramecia. So they're all basically just reacting to this negative polarity. And then when we hit this, we can do a game overlay. Loading paramecium goodness. There they go. So when they run through the center of the ring, it gets picked up. There they go. So now we can basically, if we hold down the controller, we should get them hurting in different directions. Let's have them go down. Good. Let's have them go up. All right. Back. Turn around. All right. So you can kind of try to swarm them around in a circle. There they go. All right, go up. All right, this way, back again. See how fast if I can beat your score, Keith.
I think you've already lost.
Oh, all right. Okay, back again. So you can learn some tactics. You can get them to just kind of spiral around. There they go. I'm on a few more. One more.
The last one for the challenge.
Come on. Yeah, come on. Yeah. Ah.
There you go.
All right, 1 minute. Thanks. All right. So that's the game, and I think we'll have another, half hour of gameplay still out there. Well, thank you very much. Any questions?
Knowing more about the game and the eventual Kickstarter, come over to the table and please sign up on our mailing list.
Yeah. Yeah.
Thank you. Yeah, any questions? Please shoot me some questions.
Anybody have any questions about
Sociological questions to technical coding questions?
Yeah.
Anything in between?
Anyone want to know how the motion detection works? Nobody? So actually, that's probably the key component of that made the app challenging, is that to typically do what picking up on the motion of the paramecium is known as multiple blob detection, which is basically trying to get the center of every moving organism and keep track of them all at the same time, which is very computationally expensive, especially to do on a mobile device. So when we first tried to do this, it was like, 1 frame per second, which was totally not doable. So we ended up coming up with an interesting kind of workaround. So what's really going on there is the first thing that's happening, you saw the raw feed when Oliver was showing you just under the microscope what it looked like, right? So from there, we ran what's known as a high-pass filter, which basically only anything that's moving quickly is still there and everything else becomes black. But then there's not really too much to see. So then we applied a luminance filter after that, which then takes anything that remains and makes it white. So that's kind of what you're seeing there, those white blobs. But the way we actually do the hit detection, which was the kind of key innovation that we needed to do to make this work at a reasonable frame rate, is although you don't see it, what's really going on behind the scenes is I'm using a pixelation filter to kind of turn it into like, Nintendo style. So making boxes, pixels that are the same size as the rings. So after all those filters, if there's paramecium in a particular box, it's white, and if not, it's black. So then all I have to do is the box white? Then collect the ring. If not, leave it alone. So that's how basically the motion detection is able to work at like 60 frames per second, which is what we needed to do there. Anybody have any questions about that or anything else?
And you do need a heat sink because those iPhones get really warm.
Yeah, especially on a hot summer day.
What is the Kickstarter project that you guys are going to be proposing?
So we're still working on that, but it's going to incorporate an app that's available, and it's really the customizable component is the housing, the chamber that can regulate the paramecia. Everything else, the Arduino can be externally supplied by whoever purchases it. But really, the core is the control surface where the paramecia live. So that needs to be, right now it works, but to make it really kind of robust and plug and play. That's something that we still need to work on, so it is really super reliable and people could use it repeatedly.
Yeah.
So it would be the app and the paramecium and then the microscope.
Yeah.
Yeah, one kind of modification that, maybe it would be like a stretch goal or something, like what would be really awesome to do is, I'm not sure how many of you people would remember things in the 80s, but they used to have these little like customized little arcade mini machines for like Frogger and Qbert and that kind of stuff. So it'd be really nice to make sort of like a custom housing where a mobile device would just kind of slot into it and maybe make different, like right now the stage is just one flat thing the paramecium are swimming in. But you could sort of conceive of sort of specially engineered microfluidics channels to make sort of different games, like if it was kind of like this, the overlay could be kind of like Donkey Kong or something like that. So you kind of make this console where you can slot in different cartridges and play different like biological games. Maybe 2-player games, that would be cool too.
So don't the paramecium either die out or multiply and just become uncontrollable?
Yeah, they do. They won't totally take over the world because they're in a little jar there. You have to take care of them. There are lots. You can buy a vial for $7, and there's like a little wheat kernel here that they eat on. So, it's like you have to take care of them, right? It's like you can't leave them out on a sunny shelf and forget about them.
So if you make a commercial game, how are people going to feed them?
Yeah, that's a good question, and we got them from a vendor, Carolina Biologicals. You could, go out to Central Park and scoop up some pond water, and you'll have tons of paramecia. If you don't want to do that, you can go to Carolina Biologicals, and for $7, they'll give you a jar that you can essentially feed yourself and maintain in water and a little bit of rice grains in perpetuity, because they'll just divide and divide and divide. As long as you don't forget to feed them, they'll just keep living. So we were thinking about offering like a voucher that you purchase the game, and you can get your sample shipped to you when you're ready from Carolina, and have your jar of paramecia. Yeah, exactly.
On that point, another thing to kind of think about, like I'm not sure how feasible it would be to do, but if you could almost kind of make this thing kind of like half a aquarium, half biological system, where basically like a bioreactor where they would constantly, have food in there and they would just live and reproduce like kind of forever, and then you just have a channel that kind of lets some in, lets some out.
That's like the PlayStation 4 version.
Yeah.
Okay.
Yeah.
I think we have to, one more question we have to wrap up because the other speakers can put.
Roughly what voltage are you using the pulse width calculation under?
5 volts?
Yeah, 5 volt, whatever is coming out of the Arduino. So yeah, they'll respond down to like 3 volts. So very, very small voltage. Yeah. Thank you.
If you do have more questions, these guys will still be set up outside for the last remaining time. So if you want to come by and see them, by all means, please do.
Thanks.
So
Thank you.
We have sound.
There's a Tony effect and an angle. Okay, let's stick that. The small one and gives them my own. It's just the girl's take. Thanks. So for our last presenters of the day, Zach and Momo have brought with them the Google Talking Shoe. These two I always expect surprises from, and always good ones, so I don't even know exactly what this is, but when I saw them sign up, I was like, this will be good. So I'm dying to see what exactly it is. I'll leave you with that ambiguous beginning and let you take it from there.
Super, thanks Tom. So we have a company called Yes, Yes, No, and there are 3 of us. 2 people always say yes, and 1 person says no, like all the time, and that's where the name of our company comes from.
Yeah, it's I do electronic development. I come from a documentary film background. Marcella should come up. She's an architect, but we use her for everything, almost like hardware related. And Zach does software mostly.
And we're an interactive agency, and when you say the word interactive, people think of clicking and mouse and so on. And we're really trying to do new, strange things. This is what our studio looks like. It's usually a mess, like a disaster. And we're trying to do things with software, to make things that are interactive, that understand the body, that understand gesture, that understand movement, and amplify it and create something magical. And also do things with hardware and build kind of custom, unique hardware for creating strange experiences for people.
Yeah, I would say the purpose of our projects, hi Carla.
Yeah.
The purpose of most of our projects, we want to make projects, and we want to make projects that make people happy. And Arduino kind of become a tool for us to be able to do things like that. Let's start with, you want to say this is like a normal day in the studio?
A normal day, like we're
just an R2D2 laying around?
Our neighbors.
I would say it's more like a month without sleep. That's where the R2D2 comes from. Marcella 3D printed all the pieces with 2 MakerBots running at the same time, I think.
So we're going to talk about 3 projects. We'll end with the Google Shoe, and we'll go really quickly. The first one is called Connecting Lights, and this is a project for the Olympics that was along Hadrian's Wall. Hadrian's Wall is in England, it's the border of the Roman Empire, and it goes across the country. It's a really narrow part of England, but we set up weather balloons that light up and talk to each other across the countryside. So here you can see the wall, and actually the wall really doesn't exist anymore. It's more like an idea of the wall, and we set up these balloons on really kind of, sort of insane geography. And we used Arduino to help us prototype this animation, and the balloons communicate through radio. And so they send signals, really pulses of light across the landscape.
It's like 80 miles. Right?
How many were there?
There were about 300.
Our goal is 500 weather balloons light up at nighttime and talk to each other. We were able to set up 300 because the weather was kind of extreme. But Arduino had been pretty reliable this whole time. Yeah.
Yes,
Where
Bob.
did this project come from?
It was part of the Olympics. They have a cultural Olympiad going on the same time as the Olympics, where they commission the London 2012 Olympics. So they commission artists to create, projects outside of London, so that people that are coming to the games would go and see other parts of the country and maybe travel, just see something besides London.
Yeah.
So yes, Bot, you want to talk about?
It's a robot that goes around and gives away candies. So at the Rome Maker Faire, Intel has launching their product, the Galileo, the Intel Galileo, and they invited us to build something for the Galileo. And we're like, hey, let's make a robot that gives candies away for kids.
And the Galileo is one of kind of new products that we think are interesting, which is combining an Arduino and a Linux computer in one. So it's actually like a full Linux stack. So you can run Arduino code, but you can also SSH in and talk to the device and have like a web server on it and stuff like that.
So we were running the robot as a web server. We connect the web server via like a web page on our phone, and then we're able to control the robot, dispense candies, and move around the Maker Faire in Rome. So it was.
This is my favorite. There's 4 buttons for movement, and then there's a candy button, which is really important, and a speaker. And then this is the CEO of Intel. I don't know if he knew what to expect when the robot met him on stage.
When the robot was on stage, I didn't have time to fix it, so it only turns one way, and it has to like go through the stage and turn to where Massimo and the CEO was. So it has to always spin 360 degree before it moves forward. It was a really nice moment. It was like dancing.
And we also at Maker Faire, obviously, it was swarmed by kids.
Yeah. Kids are fun, and we also brought the project back to New York, and then we went to a classroom where kids are. They all sit very nicely waiting for the candy, and then we brought it to a Halloween party, which is really crazy because there's like hundreds of kids like every 10 minutes, and everybody is like, it gives away candy, so they like all go towards the robot, and I was the only one there. And the parents was also yelling at me because they're like, why don't you give my kids some candies? And I was like, the candy was like giving out in the first 30 minutes. So it was like very stressful moment, but it was really fun. That's what's inside.
So it looks really like slick on the outside, but of course the inside is like.
It was awesome. It was like water bottle, 3D printed piece that doesn't really work so well, but it works throughout like the whole month. And the wiring was like, it's okay.
Yeah. The last project is the talking shoes that we were approached by Google to make some sort of strange object for South by Southwest that you would wear, and we suggested this idea of creating talking shoes. And
they're like connected objects that interacts with you and knows what you're doing and kind of give you feedbacks.
So this is some of our initial early prototype. I love it. It looks terrible. It broke every time you wore it.
Yeah, I have to tape it down.
And recently I saw this picture. This is like the initial prototype of the iPhone with all these pieces, like actually like a phone on the table and all of these pieces. And I sort of like it. It's like always the initial prototype sort of looks like this.
Yeah. And then we kind of slim it down a little bit till the end, and like we had to take apart a lot of shoes to be able to do that. And we prototyped the sensor pad. It's like a shoe insert with papers, and we just taped down everything.
So we got very serious about thinking about the sensors, like how could you actually sense the movement of the feet? So we have FSR sensors in the shoe, embedded in the sole of the shoe, three sensors that could actually tell you different things, like if you were jumping or what part of the shoe you were landing on, as well as accelerometer and...
Can I show them the first prototype?
Oh, sure, yeah.
Yeah, so we did a first prototype that is like a strap that you strap onto your shoes. And then there is just one sensor in the back, and we kind of know if you're tapping your feet, like if you're moving fast. And there's only one feet. And then we got invited to do the second version. I don't know why. But then the second version was like, let's do 2 shoes and 6 sensors with like accelerometer, like everything that's inside iPhone that's put inside shoes. So we prototype with Arduino first, and then we move on to building our own board using Arduinos, and we're using like some XPs. And This is not China. This is in Brooklyn. The studio looked like 2 MakerBots and a bunch of hardware and like fabrics.
Yeah. And then
With
we were
Asian and South Americans working very hard.
and then in addition to just making all this stuff, we did a lot of testing. So we literally, like, all we were doing was running and jumping and a lot of stuff like this.
Can you jump? This is the one I was like, did you say?
Skinny jeans must have been chapping. I like listening to industrial music while I run.
So this is before it had personality. Then we set it up at South by Southwest and had a bunch of versions for people to try and kind of run around with the shoe. When we've gone through different iterations, this is the sort of second iteration is actually pairs of shoes.
Because that was on our way to France, went to Cannes Media Festival, and I literally have like a suitcase full of shoes at Talks.
Google has unveiled a talking shoe that comments on your running performance. Wait till I tell my friends about this.
So this is some kind of PR video, but you can actually see, like, there's a nice part where you can see our development.
From off-the-shelf components that anyone has access to. The project gave a sneaker a voice and a direct line to the web. I'm sorry, am I interrupting you? Using a series of sensors, an onboard speaker, and a mobile phone, the sneaker comments on everything the wearer does in real time. It nudges them. This is super boring. Motivates them. That's more like it. Gets them in the game. Call 911 because you're on fire. It pushes content to their Google Plus feed so friends can listen in and reply. Breaks over. And it can post directly to dynamic banners engaging the entire web. The talking shoe debuted at the Google Playground during
So it was really fun, like when you make this thing, but also actually setting it up and letting people try it and giving them a kind of a means to, not just making an object, but wear it and test it.
This is hysterical to me, but it's also really kind of cool.
Top 10 things you don't want to hear from your sneakers.
We'll end with this. This is my favorite picture, our favorite pictures of this project. This is actually the airport security guard. We are trying to travel with these shoes, and you can imagine how weird they look. Like every time we get stopped, or we think we're gonna get stopped in the airport with these, it's like crazy to have a shoe that has electronics in it, and they always pull it out, and they always want a demo. And there's something like, I love creating like you create magic for people. We created magic at South by Southwest, but we also created magic for this security guard for his day, and like it's really wonderful.
Yeah, he was really happy when he saw the shoes.
And so all of these projects are about creating magic, and with all of them, we've been deeply, I would say, blessed to be able to use Arduino and prototype really quickly and build weird experimental hardware for people to enjoy themselves.
Yeah, I got some questions earlier about we're artists and how do we work with companies like Google or Intel to build projects that's kind of not their everyday project. But I would say it was just because really we're able to use these tools and prototype things really quickly and work with technology and always kind of develop new technology to work with us, which is a really good thing. Thank you.
Any questions? Or yeah, thank you.
Thank you. Wait, what? I brought some stuff that we work with, so you feel free to come up and play with them.
Any questions about these projects? Yeah.
Do you sell them?
No, we don't sell them. I would love to sell them, but no, we don't sell them. They're more.
The Yes Yes Bot is gonna be kind of touring a little bit in April. I think the first day in April is the Brick Media Center, and in the beginning of April, if you just look on their website, we're gonna bring the robot there and kind of give away candies again.
Did you need an Arduino for each shoe?
Yes. So for what we're doing for these shoes are communicating to each other over radio and then communicating to a phone over Bluetooth. And so
we do use Arduino in both shoes, and then we use file first, and then we move on to Teensy, but we always prototype with Arduinos.
But you need one for each.
Yeah. Yep. Yeah.
What do you do for batteries?
We use those small LiPo batteries.
The 3.7 volts.
Yeah.
they're in the sole.
Our system is on 3 point.
They're in, like, the high tops are really good because the sole is sort of thick, and it's like a perfect place for a battery. So, so how much did they cost?
How much do they cost? Did anybody laugh at that?
Yes, that.
I would. It's really hard to say, but all these things are kind of you can find in like a maker shelf kind of.
Yeah,
store.
Nothing in here is really fancy. So we're using like $20, or we're using Teensy's like a $20 board or $20 or $30 board.
And first prototype, we used the Bluetooth module, SD card from SparkFun, so you can kind of know if you go on the website, find these parts, you know how much they cost.
Say like maybe a couple $100. I'm not sure, but yeah.
Google commissioned you guys to make this product? Okay.
Yeah.
I see. So are those custom shoes like from Google or?
No, they just like they had some sort of partnership with Adidas, so we just kept going to getting the shoes at Adidas.
We have some branding on the shoes, but it's not like specially made for this project.
And we became the favorite customers of this. There's an Adidas store in Soho, and we would come and we would have like the SKU numbers, and we'd come in and be like, with
I
this
want
like
20 pair of those.
like nobody comes in and orders that many shoes, so we were really well known over there. So yeah, we just put labels on them.
What did you get by using 2 shoes instead of one? Like, what was the meaning?
I mean, one of the difficult things is detecting jumps. So you could detect it, with one shoe, it could be like, if you really move upward, if you have a lot of acceleration and you're off the ground for a long time, then we would assume that that's a jump, but it was really hard to tell. And there were a lot of ways to get false jumps with one shoe, but with 2 shoes, you could actually really know when your feet are off the ground. And it was helpful for detecting things like spinning and kicking and things like actions that are hard to perceive with one shoe, but if you have 2 shoes, you know that one is stationary and the other is doing something. So we were able to improve the logic.
I think at first we wanted to know if we're sitting on the couch and have one leg up on the table and the other leg was like on the floor. So that was like the beginning. They want to know this kind of scenario and what to respond with them. Because the shoes have characters. There's like 5 characters related to the shoes, and you'll be able to choose from the phone app. So you can choose like who's gonna talk to you and what kind of things they're gonna say to you. Like there's a Williamsburg hipster character. It's always very sarcastic.
Yeah, she's always
like
toxic.
she doesn't talk nice. And there's a guy with British accent. Yeah.
Is it an open source project?
This one.
I mean,
Did
I
we
think-
put all the code? Yeah.
I think everything is on GitHub, so.
We just need to organize them a little bit.
But yeah, actually, like,
I think
I think all of these projects are on GitHub. So.
Yeah.
Did you need any like major heat sinks? How much weight did it add to the shoe?
We don't need heatsink because there's nothing really. It's running on 3 volts, and all the sensor they're very they cost very minimum.
You put some gyroscopes in there, I guess.
Yeah, we had like a IMU unit in. So I don't know if any of these are made up. You can see here actually. This is like what the sole looks like. There's 3 FSRs, and then there's here. This is an IMU unit that is getting acceleration and gyro and stuff like that. So yeah.
So how much current did it draw?
It's like milliamps. It's not a lot. It's like no more than 1 amp.
Yeah, but actually it's really crazy because there's all these like conditions with shoes and electronics because your foot is sweating and you have there's a lot of funky stuff that's happening in your shoe that it's really like a weird engineering challenge to one is wear things that you're wearing because you're constantly there's a lot of weight on these sensors, but also there's so many funky things happening in your shoe,
Like,
sweat and
oh, I mean, how does that impact this?
So we were launching at Cannes in France, where it's actually really hot there, And for some reason, like, I don't know, it's like one of those Google Glass thing where our shoes is the size is almost for guys. So it's not a lot of girls size in the shoes. We have like from like maybe size 5 men to size 14. Does it go up there? So when we're testing, a lot of guys like wearing them and like everybody just sweat a lot. And we were like almost fixing all the time, and then we realized actually they don't do very well with moisture. So what really impacted them is the electronic gets wet. They didn't get so much protection. They got wet, and then they stopped working for a little bit.
Yeah, so for example, for a commercial iteration, we'd really think about how to laminate this and like make some replaceable unit for because this is like, you're putting a lot, when you start jumping on this thing, you're putting a lot of pressure on it. It worked for these demos, but if you want to make a product, that's one reason why it's not for sale, is that there's a lot of stuff still to figure out. So.
It's a working prototype, but because we have to do the shoes very quickly, so we build these little 3D printed pieces that holds everything in place. And we got to go to MakerBot and they help us, the factory help us, and it gives us like tons of colors. It just everything comes in color. It looks so pretty.
Yeah.
We don't get to do them on every shoes, but it's really nice. The P's are up here if you want to take a look. And so these are the sensors that go inside. They're very sensitive. They can measure up to 100 pounds. Yeah, we really like them. Sorry, what?
Yeah, normal FSRs are not good for like so much weight. Like typical.
No, it just weight. Yeah. They just have higher.
They're rated for more weight.
Is there a turn off button, or is it only for the phone?
There's an on-off switch on them because it's sometimes it's like super annoying because we had like these like kind of fancy Google execs walking around with them, and they need to turn their shoe off because they have a meeting or something, and the shoe just keeps talking back to them. And when they start standing still, the shoe actually is like goes a little bit, gets more tough with them, and it's like, come on already, like breaks over, and they just like it gets more challenging. So,
some of them got really mean when you're not moving.
Yeah.
Okay.
Okay. Thanks so much.